Good morning, everyone. Oh, hold on. There we go. YouTube is trying to get me to add advertisements to this, so I'm trying to stop that. Good morning. This is a very rare main channel live stream. How's everyone doing? Normally I would have cleaned up around here, but live streams are more raw. So you're just gonna have to deal with it. This is a side of the channel you don't usually get to see unless you go over to my live streaming channel, which should be linked at the bottom. Oh, actually, no. So yeah, welcome to chaos, as it may seem. Hope everyone is doing well. We got a special treat for you all today. We're just going to let people trickle in here first, and then we'll get to the main thing of the stream. But maybe first I can show you guys a little something. I don't know. Actually, you know what? I'd have to look back now because I don't even know. This is probably circa 2015, 2016. Don't know if you guys remember this guy. So this is a racing quadcopter I had built a long time ago. I wish I would have put a date on it. But I haven't flown this thing in a very long time because pretty much the whole world put restrictions on drones. And in Canada here, if it was over 250 grams, you needed to get a license, and all that stuff was up in the air. So I ended up not getting a license, so didn't fly this thing anymore. But now I've got my drone's license. So not only am I going to make content around this, the ZMR 250. We're going to get some footage for you guys. We're going to go over, how this thing was built and all that cool stuff. But I have ordered a 7-inch drone. A 7-inch would be 1, 2, 3, 4, 5, 6, 7. Would be smaller than the ZMR. Does that make sense? 1, 2, 3, 4, 5, 6, 7. Using my scale at the bottom here. I thought I was building a bigger drone. Well, I got a second drone on the way. Good morning. Audio is very low. Okay, let me fix that for you. Oh, shoot. That should be better. That's because it was picking up from my podcasting mic. Sorry. Is there still a buzzing now? Okay, fixed now. Good. So I was just talking about how this is my drone that's been shelved because of licensing and whatever in Canada. Now I'm a drone licensee, and so there's this drone. We're going to talk about the old way of making drones. This is circa like 2015-ish. And we're going to talk about the new way of building drones because I have a new one on the way. And in fact, the prices have gone down, not up, which is crazy because these things were not very expensive. So yeah, the only thing is I have to register the drone. I have to put the number somewhere underneath here, but I'm going to think of a solution to that. So today is not about this. I'm just letting you guys file in as I get ready to go here. Like so. Today is about Aecert Robotics. So you guys certainly remember Acert's podcast appearance. So he was nice enough to send me a hardware kit, this right here, for his RC controller, which is all the bits and pieces over here. So I printed all this. Hopefully I've got all the parts. And then we're going to assemble his PCB. We're going to put it all together. Hopefully it's going to work. The only thing that worries me is that, so he uploaded the code onto this, which is good, but there's demo code for making servos move on a receiver, and that I'll have to, code, or not code myself, but upload the code myself. So yeah, it's going to be interesting to see if I can use his example code with Platformio for the first time. So that'll be interesting. So let's get to it. Let's unbox this, see what's inside. I'm going to lift this up a little bit so you guys can see. Need some spool boxes. Here's a spool box. Kind of dusty. A spool box. Morning, Johnny. How does it feel to be on the main channel watching a live stream and not on the live stream channel? It's a bit different. I don't know if Franco is going to be here because I don't know if he's aware of main channel live streams. No, I don't know where my other spool boxes are. So, spool it is. There we go. Didn't notice. Oh, there we go. So here is the box. I have not opened it. See, tape is still sealed. He assured me that he double-checked that it was all in there, but you never know. Stuff happens. So here it goes. Cut into there. This is the P.O. box. I sent this to the P.O. box. I didn't know if any of his information was private or anything. Oh, there you are. Morning. Oh, thank you for there's a typo here. I didn't purchase the kit. This was sent to me free of charge. However, I can say anything I want about the kit because here, let me shade that so you guys can see it. Because that's just the way it works on YouTube. However, I do believe that that this project is super cool. Let me just let me see. There should be a packing slip. Pre-order. Yep. That's good. By the way, links in the description if you guys want to get your own. What's this? All right. For more info. Oh. Is it? It's a little bit too bright. That's okay. Full video tutorial, written tutorial, parts list, STL files, hexapod specific RC code, generic RC code, receiver example code, much more. So we're going to probably need this. You can join the Discord if you want. There's the QR code for that. Hopefully these QR codes are not for purchasees only because now everyone's got them. Sorry, Aecert. All right, let's take a look at what's inside here. Piece of foam. Oh, wow, there's a lot of stuff. Okay. We've got some screws. These look like M2.5, maybe M3. They're countersunk flathead screws. We've got, looks like one rotary encoder, 2 potentiometers. Looks like that. Some battery contacts. There's an interesting way that these battery contacts have to be installed. So we're going to see if we're going to do it that way or if we're going to do some custom work. Some self-tapping screws, very small, probably like M1.8 or something like that, M2. We've got some of these sort of Molex style small connectors and their plugs. So we got 5 of those. I think you only need 4, maybe 5. We've got a couple little caps, some female pin headers. Ooh, they are custom cut. So I don't know if you can see that live edge there. They are custom cut, so that means they won't be butted up right against another component because when you custom cut them, they never end up with a flush edge. Oh yeah, they're custom cut on both sides. All right. We've got, that's our 6-axis gyro. which is pretty cool. There's a 6-axis gyro inside the controller. These are 2-position switches. Yep, 4 of them. We've got our main power switch, 4 little micro switches with the little blades on them. We've got 4 tactile push buttons with a long reach. We've got 2 potentiometers. They look like an Alps type C and K, probably something you can find in like a PlayStation controller or Xbox controller. We've got our Arduino. Oh, there's a smiley face on it, so probably this has been, well, I've been told it's been programmed, so that's good. So this is like the Mega Pro embedded. Sorry if the focus isn't working. And the pin headers that are coming with it. It's good. You're going to need to solder this onto the board. USB Type-C. Always a good choice for boards. Not a fan of USB, Type-B printer cables, nothing like that. We've got some heat-set inserts. These look like M3, so those screws must have been M3. We've got the NRF24L01, my nemesis on this channel. Your focus isn't working either? Yeah, that's good. So we're all in agreement then. So this is the high-powered one. This one should have good range. However, it is very sensitive to voltage fluctuations. So I'm hoping that since I'm going to be using a regular 9-volt battery, I'm hoping it doesn't crap the bed. Oh, also, if you look at this one, Chinese QC, the antenna is canted over. So hopefully that won't be a problem. Here, maybe that's more obvious if I put it like this. I do have a couple of these, but maybe not this specific version, so hopefully it'll be good. We'll do this one. LCD. Now this is going to be a kind of a pricey component. Perfect QC. Yeah. It's going to be a pricey component to source because I believe... Is this a... no, yeah, it's not an LCD at all. It's an OLED. So an OLED just means that every pixel is its own LED and there's no backlight. So this is not a cheap part, just so you know. These kits are on pre-order, by the way, link in the description. Just go to the website. You may have to bend it. Yeah, we'll see. I mean, I can just desolder it and move it. And here is the custom PCB. Who's the board manufacturer for this Aecert? Is this PCB? Oh, PCBWay. Idiot. Shana, manufactured by PCBWay. So yeah, aecertrobotics.com. You can get into the pre-order. Looks good. I don't see any backtracking. A little bit of a acid trap here. These look good. Just trying to see the traces. Mostly single-sided routed. You can see some routes on the back, but mostly this should be a ground plane. Look at that. Beauty. Anything else in there? Nope. So this is in a custom looking box with shiny finish, so you're getting quite a bit of quality. So I actually, if you go look at the price of the pre-order, it's not really that expensive. It does save you time hunting down components, which is nice. And if these things are going to come programmed, then that's already worth it. Let me show you his design for the controller. So here is the front. Now, I've printed this a couple times. I'm going to hope not to get them mixed up. This one here is printed in PLA. But the problem is it was printed with a 0.6 millimeter nozzle. Zero support So you can see a little bit of the overhang there, no support. You really should have tree supports on here, but as you can tell, this printer printed a little bit higher quality than this one, but this one is in PETG and 0.4 millimeter nozzle. That's probably what you should be using. First person uses this PCB version. Hopefully it works. Yeah, let's hope so. So this one is what I initially wanted to use, but the front of this, where did the front go? Hang on a moment, folks. The front fell off. Anyways, the front of the PLA version printed with the 0.6 millimeter nozzle, the holes were too small for the little button springs to fit in. Where is the front? I have no idea. And then I also printed it because I had to revive another printer. So I printed it with some spare PETG. So we have red and black to choose from, but I think I'm going to go black. And then the other thing to keep in mind is that I printed my parts on 2 different printers. Let me throw this over here. So here are the accent pieces. So these are from the Voron V0, and they did warp a couple times. I'm having like weird issues with my V0. Stuff isn't sticking, and I have the same problem with my Elegoo Neptune. Nothing is sticking, but the Chinese build plate I have on the revived Chinese printer, that thing sticks like nobody's business. So yeah, we'll have to see. So all this stuff is ready to go. This is the color scheme I'd really like to go for. And as you can see, I have to trim a little bit to get that to fit, but sort of like that. Purple and black. Because purple is the channel color, and black is just what I have in bulk PETG. And these are PLA pieces also, so that may cause a problem. We're going to see. The purple is PLA, and the black is PETG. All right, let's get to her. Let me see here. Like that, like that. Here are the assembly instructions. So you guys cannot see that. But also we have a YouTube video to look at. So 2 to 3 hours, you know, since we'll be messing around on stream, it's going to be more. If you don't know how to solder, learn first. Yeah. So here's Acert's YouTube video. Files, 3D printing, handles, case front, back, button springs, screen spacers, soldering here. So we're not going to watch his copyrighted content. We are going to, PCB way. Oh yeah, and he says there's the order is important. Push buttons on the top of the PCB. So let's see what we got here. So is there anything indicating the top? There is not. I'm just assuming this is the top because I see the switch and everything. So we're going to start over here. Where is my soldering helping hands? Over here. Stuff just avalanching to the ground. Oh yeah, I should be grabbing 4K footage of this too. Yeah, we're going to deal with that later. Like so. Get in there. There we go. And there we go. Squish. There and there. Good. And you guys need to be a little bit closer, so let me boost you up a little bit. Oh, here's another filament box. It's going to make an avalanche though when I remove it. That wasn't too bad. There we go. Maybe I'll just use this footage for my stuff. And let's make this a little bit closer. Properties. Configure video. Camera control. Focus. No, not automatic. Huh. It's like, seems to be parked right where focus is not great. That's as close as I'm going to get it. I really should have used my cell phone for a webcam here. Aecert was doing that yesterday. It looked pretty damn good. Okay, push buttons on the front. Let's turn on the soldering iron too, that might help. I'm also going to taste my coffee with a new sweetener. Some like monk fruit extract. Okay, first things is I didn't really use enough sweetener. All right, let's get these bad boys in. And 2, 3, and 4. I'm going to clean up the soldering iron, take out the nice lead solder. Can taste the brain cells leaving my body. And I will solder these. So these push buttons, just a little pro tip, you can solder them from the front. And that means that you can solder them while paying attention to if they're sitting level or not. So normally it doesn't really matter. However, if you have a case that is dependent on the orientation of these things, then it's nice to be 100% sure that they are sitting flush. Get in there. I have to work around my webcam now. 2. 3. And 4. There we go. So they should be absolutely flush, which they are. And now flip them upside down and do the rest. Yeah, you like that, huh? Ask me how I know, because I place things wrong sometimes. Basically, the more mistakes you make, the more tricks you'll figure out. I always tell my apprentices that I've made more mistakes than they've made attempts, and that's why I got where I am. All right, so there we go. Flip this back over. Next step, place the pins onto the bottom of the PCB. I need a visual for that. So let's swap to the screen. We're going to swap to, I'm going to swap down here
All right, so he's got the long end of the pins pointing up. So we can do that. Lead solder, yeah, much easier to use. It flows better. It has a slightly lower soldering temperature, and it also it has a less critical point. Like it's more forgiving, essentially. Lead-free solder can be very fickle. If you overheat or underheat, you're going to get bad joints. Okay, do I need these pins? They're there, I guess I do. All right, so the long ends have to be upwards. Oh, these are tight fitting, which will make it easier to solder. That's good. Like so, and like so. Just going to double check that he put the long ends up. So screen, see, yeah, long ends up. Making sure they're flush. Yeah, all the pins are needed. That's good. Back to webcam. And then I'm just going to put these here for orientation. So you slap that in there. Looks like we're just about lined up with the silk screen. And I'm going to hold this. And when I solder, I'm going to push up on the board. Just making sure now that I have to solder the bottom. Yeah, yeah. Oh, he's done that too. Settings, playback speed, 1.5. Yeah, he's explaining something. Oh, are we soldering the... We're soldering the Mega first? We are soldering the Mega first. Okay, that's fine. Okay, so I don't have the right tip equipped for this, but let's try it anyways. I'm gonna just get my visor. Since I have to give you guys, like, I've got that much space between the board and the camera, so I'm going to put on my old man glasses so I can stand a little bit further away and do this. Now, I don't have the ideal tip. I have a chisel tip, but chisel tips let you push a lot of heat quickly. So, here it goes, for better or for worse. Doesn't matter what you do first. Okay, that's fine. I'll do this. Here goes. Get in there. I can see how for beginners this is going to be the more challenging part, and because you need the long pins upwards, that means that you can't just order these modules pre-soldered, because they always solder the long pins down. But if you're a beginner, what you can do is solder the outside row, like this row here, and then snip all the outside row off, and then go in and solder the inside row. So, like so. Okay, that's one row done. The inside row, wow. Yeah, this is not, this is not ideal for this tip. So I think I'm going to follow my own advice and snip off the outside row. Yeah, that's, I'm glad you like that. That's just from my struggles. So to snip these pins, first of all, wear glasses because they go flying everywhere. But what you do is you set your cutters in place and then just put your thumb over it. And then there you go. Don't press your thumb hard into it because they do come up. It does, like, if you're not a seasoned vet, your hands will hurt doing this. If you're not like if you don't have calloused hands, like it feels like an electric shock almost. So your hands might get a little tired of feeling that. But I suppose you could do something like this. You know, it's not very visual. Whoop, that one went flying. I'm going to be finding these things in my socks for months. Morning, Dave. Better late than pregnant. Oh, look. That one shot through the foam. You see that? So, yeah, like it can be a little painful. So if you don't have calloused hands, use something like that. All right, next one. One may have landed in my coffee, but that's okay. Little lead in the morning. All right, here goes. So yeah, now you can get in there. I think visually it'll make it a little bit prettier too. I'm not sure if I'm getting all the way down there. I'm looking around my my visor. Get in there. You'd think with the amount of live streaming I do, I'd have a better live streaming soldering setup. Oh. Just want to go back over and make sure they're properly in there. Yes, all right, let's see if we can get this bottom row. Can snip all of them, but I want to finish my coffee first. All right, here goes. Just remembered about this. Well, that's why you put on the notifications. Get notified. Actually, I don't blame you. I don't have notifications for anything. Because if I'm around YouTube and it's time for me to watch something, I am actively looking for something to watch. But if I'm busy, then it's not like a notification would help because I'm busy. So I'm not doing YouTube stuff. So I don't blame you at all. Here we go. Oh. Okay. So I think this one Shouldn't be too bad. Just by this crystal here, it might be a little difficult to solder, but it shouldn't be too bad. We'll just flip her around. My my poking skills are not very good. Going around. Oh, there we go. Yeah, it is still better. Like, look at the steep angle you need in order to get in there. You also have to make sure that you're getting the heat on the pad, not just on the pin. God, I love these embedded Arduinos. They're just a bit of a pain to solder. I would love to see this revised to feature the RP2350, the new one. It is a much more powerful chip than this 2560. It is much more inexpensive, and you can get them in stamp formats where you can just, it's like super easy to solder. No pins. It's just like SMD cutouts. The 2560 works as well, and I think there's a couple limitations for the 2350 chip that the Mega doesn't have. Like, I believe this has more analog inputs, but I think the potential is definitely there. If I were a coder, I would give her a shot. There's also another thing that I would say is that protocols. So ELRS, since I'm reading up on modern drones, ELRS is a protocol, open source protocol. Estimated build time? Oh, I don't know. It's a bit different when you're filming. When you're in the zone and focusing, it's different. So I would say, I mean, I wouldn't be surprised if it took me way longer. But like, just seeing the soldering here, like, it's not bad. Just a lot of solder points, solder joints. Another consideration, Aecert, for in the future is to build your Arduino right onto your PCB so that you can sell a finished PCB where you just attach the switches, or even just have PCB-way attach the switches. So either that, or have a socketed version where people can just get the pre-soldered module, and PCB-way would put the sockets on, like the female headers. Just if you care about accessibility, this is perfect for makers. This is fine. Can't sit and watch. Yeah. I mean, you can watch the VOD after. The VOD will be up. Don't subscribe. YouTube will play Islam propaganda? What? Oh. Oh, geez, I missed what you said up there. I mean, how do you know it's Islam propaganda, though? Unless you speak Arabic. Or maybe YouTube knows something about you that you don't. Just gotta make sure all these are well soldered. The last thing I want to do is go and chase problems later on. That's pretty cool that they shoot through the foam. Oh, it comes out. Oh, let's not get into religion here. I get myself into trouble. Considering what you say about religion will offend people differently depending on what religion they follow, and I don't really prescribe to any of them. These are going, I'm going to have to vacuum around here. They're going absolutely everywhere. Ouch! One got me in the forehead. Thankfully, I have glasses on. Alright, these are not soldered though. I think on my last stream or the stream before that, I like burned myself and I cried out in pain and people got scared because they had me on the background. Yeah, I'm glad I trimmed that because a couple of these are not soldered. There we go. So yeah, snipping these pins off are not the safest thing to do, but I think it's fine. What hobby is without risks? Okay, that's good there. These are all soldered. I could clip these, but I'm getting a little bit tired of being hit. So everything looks good. Now we still need to solder these. However, these should be much easier because they are kind of flat. Is drinking a hobby? Yes, it is for some people. Do you drink? I can see why if you're a Subaru fanboy. Kidding, obviously. The board does look very cool. Yeah, I'm sorry. I shouldn't have came for your Subaru. I had to do a front lower ball joint on a Subi. And the pinch bolt was so seized in the knuckle that I got the knuckle to a molten state and it still wouldn't come out. So we ended up drilling it out and putting a longer bolt in and a nut. I did hobby drinking this weekend. Was down in Skpan for a whiskey tasting. Interesting. Threads, yeah. Welcome to owning cars in Salty, Canada. So in a moment, when I'm done soldering this, I can take off my visor. I'm going to check my forehead because it feels like where I got nailed by the component leg, the pin, feels like I'm bleeding. Just a little red Loctite, you know? Hang on, let me see if it's just all in my head. If it's in my head or on my head. Nope, no blood. All right, we're good. Aecert is American, so we have to be careful about who we say is drawing blood. Oh, shit. Okay, be careful of the buttons there. I think if I were to do it again, I would just solder the buttons from the front. And I probably wouldn't... I'd probably solder the buttons from the front after. Drinking coffee is difficult because I'm hitting my glasses. Let me take a coffee break here for a second. Bought the service manual for Audi S6, weighs like 3 kilograms. Amazon wanted $350, got it for $30. Nice. Aecert is from America. And I don't know if he's gonna share any more than that, but America. Land of the subpar whiskey and bourbon. Kidding again, that's all preference. We are in an active trade war, you know? Oh, so you guys can't see that particularly well, huh? Well, I'm going to do my best. Hang on, what if I do this? Whoop. Upstate New York. Yeah, we're like neighbors. If things were friendlier at the moment, we could reasonably go visit each other. I don't have much commentary to do. I'm just soldering pins here. Just got to be very careful to not melt the tips of the push buttons there. Also, this would go a little bit faster if I didn't have a webcam between my work and I. So keep that in mind. Also looking through magnifiers, so because I'm far away, and that is removing my stereo vision. So depth is a little bit difficult. I'm also very lazy and I'm not cleaning the tip of my iron as much as I should. That's good. Only one row left? Yeah, one row left. So somebody should check how many pins there are on the Arduino Mega, and then multiply that by 2, and that's the amount of solder joints just for the Arduino. I see one that's a little low here. I'm just going to touch it up. So far, so good. Oh, missed one right here. That would have been a disaster. All right, I'll let you guys see my handiwork, which is you're not supposed to do on YouTube. Show people your soldering or your welding. There we go. And on the other side. Morning, Kim. Welcome to the stream. So all that fluff you see, that's all flux residue that burned off. Or no, actually it might be just, yeah, it's not burned off flux. It is flux that is solidified and flaked off when I use the cutters. Oh no, that was a bad idea. There we go. Looking really good. You don't even know what I look like, but I appreciate the thought. I'm good, Kem. How are you? It's been a while since you've been in the live streams, but I'm not sure if you know about the live stream channel, because this is not usually where I live stream. All right, let's hit instruction number 2. I think that's 2. No, 3. Screen. All right. Oh, nope. Okay, yeah, buttons. Pots. So is this the one you have to clip? Have to clip a nub? Let's see. Back to cam. So we have pots over here. So these two, look, I still find that nuts how many of those legs fired through the foam. Just saw the notification while YouTube play some music. Do you make a separate channel to go live? Yeah, youtube.com/@SEstreams. Has nothing to do with Sweden. Okay, these are pots, but not in the traditional sense. It's these guys. Ugh. So these bad boys. Oh, they come with genuine cat hair, it seems. So That would probably be maybe the orange one. Watch this. There we go. Genuine cat hair. So, if you were so inclined, you could clone Acert's cat. Oh, it doesn't bother me. Alright, so this guy should fit inside here. Okay, yeah, so we have to flush trim these pins, I believe. This one's fine. There is definitely some adjustment. So I know there's like a nub you have to cut out. Let's check the written instructions over here. Screen. Here. Nope. Here. Place the mega onto the pins. Long end. Solder the mega. Yeah. On top, you'll need to snip the plastic nubs off the bottom of the left potentiometer in order for it to fit over top of the meta pins. That was a Freudian slip right there. Freudian meaning, you know, meaning one thing, but instead saying your mother. Okay, so need to snip these little guys. Probably this guy here. MCU board is a ATmega 2560, which is basically a Arduino Mega, but it's the Pro embedded version. Can't even gawk cars any longer without being political. Tesla start prices. I mean, he did it to himself. I don't feel bad at all. I am a little bit disappointed it took so long. The thing with Tesla, too, is that they are really cool cars back in 2015, and they haven't changed since. Oh, you have a Model 3? Uh-oh. You have to put the sticker on your car or else you're going to get vandalized. You have to put the I bought this before he went nuts. The thing is, he was always nuts, but just now we see it. All right, I'm going to solder these from the front. Again, keep the orientation. Teslas have now been overtaken. Pension money into Tesla. Oh, that sucks. Well, that is investment, right? Risk. I mean, anything that's in the U.S. markets right now is completely knackered. It's over. Did I mention that I will start receiving your state pension? You are old, my friend. I feel old, but you are old. But congratulations, man. Not everyone makes it there, you know? You made it. It's time to relax now. Take it easy. Cruise around in your in both your midlife crisis mobiles, I have to say. Audi S6 and probably Mustang GT. I'm assuming it's a GT. I never remember. That seemed to have gone well. That's good. All right. Next. I'm just reading off screen here. Solder the female header on top of the PCB. That is not enough info for me. So let's go to screen. I wish I had a keyboard so I could skip forward. Sneep. Oh, he snipped both. Uh-oh, I only snipped one. No, it looks fine. Oh. Oh, dry fit. I need to do dry fit. Oh, female header at the very top there. Okay. If it's flush, you're fine. Yeah. Okay, good. Whew. So female header up here. Yep. Female header. Ouch. Keep smashing my glasses. I'm gonna put it way up now. Oh, now I'm smashing something else. Great. Here. Female header. Should label the female header pins on the PCB. No, that's okay. Don't worry. The thing is, with process of elimination, I mean, if you really want to put it there, I suppose you could, right? But there's a whole extra. So my conundrum with this is to get them straight. They're not going to be easy to get straight, but I think you can lever it around a little bit after. Oh, on the front though, right? Because oh yeah, the gyro goes there. Okay, yeah, that makes sense. Yeah. These are more difficult to solder because look, you have to hold them and then put your iron. Oh, I had to bail. I was going to melt it. And then you got to grab your solder and put it there. So yeah, this is probably the most tricky for someone who's new to soldering, because you kind of got to hold it and then grab this and then grab this. Oh no, I was too slow. Because the problem is you're going to melt these pins. So you got to be quick. It's like learning to drive a manual, you know? You're rolling down the hill. Yeah, get in there. Okay, straighten that out. I think we're good. Blue tack, yeah, blue tack, sure. I'm a blue tack hater because I buy it, then I use it, and then next time I go to use it is like a year later, and it's freaking rock hard, and I gotta buy it again. There we go. That is soldered on, but I can 100% guarantee you it is not going to be straight. Oh, they're pretty. They're not bad. It's a little tweaked. That's not too bad. I was able to do it. Okay. Grab the screen. Next. Power switch on top of the PCB. Make sure it's correct orientation. Match the I and O, or the 1 and 0. That's really a 1, just so you know. I and O markings on the board with those on the switch. Yeah, that makes sense. Webcam. Yeah, 1 and a 0 because it's binary. On and off, 1 and 0. Okay, so you can also get these switches in 2 conductor, so yeah, like that, so that it's always goes on the same orientation. I for not off. Yeah. Okay, so this guy does not sit flush on the board, so you are going to have to be careful on getting it straight. These things are incredibly cheap, so these switches, so they're not, you're not going to be able to design a tolerance into the board to make them sit flat, like ever. So it's all going to have to be up to the builder. Okay, that one. And that one. I will say your video is going to be awesome for people who aren't quite sure what you mean. Your video is very, very useful. Gyro pins onto the gyro. Short pins go on the bottom of the gyro and out the top. Okay, so you've got let's make sure. Female, yep. Yep, mm-hmm. Soldered. And then short end. Okay, perfect. Look at me doing switching. I need to hire a producer that'll work for 5mm LEDs. Okay, so you've got these angled pins and the straight pins. Angled pins are spare parts. Straight pins like this. And I'm just going to shove this into the hole, but not for soldering. I'm just going to use it as a spacer, kind of, to solder the pins on. I know this is not the way they go. I'm just sitting it there, making sure. Yeah, I think so. Aecert will ring the alarm if there's a problem. Okay, just using that as a cradle. Get in there. 3. There we go. That is soldered, as the British would say. Oh, a little bit crooked. You see that? Oh, lost my, here. Ta-da! Slightly crooked, but I think that's okay. Okay, and now I'm gonna go screen, and that goes on the Arduino side, and then solder on the other side. Okay. Webcam. Yeah, she'll do. It'll be fine. All right. This guy, This guy. Very good use of footprint, by the way. The silkscreen being around, making the shape of the board. That's very important. No, I missed. There we go. I put this live stream on the main channel, but it seems like we mostly have the same crew as the live stream channel. I don't think it made much of a difference. There are like super chats enabled and stuff here, and YouTube is pressuring me to put ads on, but I'm not going to. I think I'd rather not upset people for the couple cents I'm going to get. Yeah, mine is Franco, but Franco sometimes joins late as well. Joysticks. Oh, that's okay. That's simple. Joysticks. What's the streaming time? 1 hour, 12 minutes. That's why you weren't subbed? Because you went and checked out the live stream channel? Oh, I'm off screen. Look, professional YouTuber, ladies and gentlemen. Okay, so like this and like this. Ooh, they're very loose in their holes. Turn ads off. A 6-hour-ish live stream, 10-20 average viewers. I got 97 cents, yeah. And I don't blame YouTube for trying to recoup their costs. It's expensive hosting a live video, but there's not much in it for us. Like, if you really want us to turn on, yeah, this is awkward. If you really want us to turn on ads, sorry I bumped you guys, then you're gonna have to just make it worth it. Now the case is getting hot. I'm trying to center that in the hole. Ouch. Yeah, not ideal. So, if I have premium and you turn on ads, you get anything? No. You get money whether or not I run ads. Like, I get money whether or not I run ads if you're a premium subscriber. But if you spend most of your time in Acert's streams, like let's say in the entire month, most of your YouTube watching is, Aecert, and then you come into my channel, all that does is it takes some of the money that Aecert is earning from you and giving it to me. Because let's say you pay, I don't know what premium is these days, $20 a month. YouTube will take a cut, let's say, just for sake of argument, half. So $10 a month is then divided between all the content you've watched, with watch time being the metric. So if you've watched Aecert 90% of the time, he would get 90% of your $10. So essentially, when Aecert like I'm cross promoting right now, right? I'm telling you in my description, go watch Acert's channel, go buy his kit. If you're a premium subscriber, if you're a premium subscriber, and you now watch 50% my channel, 50% Aecert, I lost half of your thing. I mean, in reality, YouTube's about numbers. So one person doesn't change anything, but it is, you know, it is what it is. Yeah, premium is the easiest way, the simplest way to support creators without even doing anything. Because like I get premium viewers account for like 5% or something of my viewership, maybe even less, but it accounts for like 15% or 20% of my ad revenue. The only thing is premium costs a lot in Canada. It's like nearly the same cost as subscribing to Photoshop. All right, so there we go. So what I did is I started by the case, the metal case, the 4 pads, and then, oh, they feel good actually. I don't know what brand these are. I have 2 things for media. I have YouTube, which I don't pay for premium, but at some point I probably will. I could actually expense it as a business expense, so like it kind of makes sense for me to get it. But I pay for Prime, and I need to stop paying for Prime, but I already paid a year up front. So I have Prime Video. So I've been using that. Gyro on the bottom, 2 joysticks, NRF 24LO1 to the bottom of the PCB. Over here. Oh, he has the pins already attached. Okay, let's do that. Back to this guy. These are not the cheapo joysticks. Yeah, they feel good, I have to say. They have good good flex, good force behind them. All right, so we're done here. We just need to get the 24LO1. Hopefully it fits through the hole. Oh wait, they're already soldered. Idiot. Thought I had to solder them onto the board. Oh, they're a little mangled in shipping, but that's not too bad because they're going to hold themselves into the board. Get in there. Oh, ouch. So the only thing I would say so far, Aecert, is just to specify which part of the board is front and which part of the board is rear. Like, it's fairly obvious, but I can see a overly nervous first-time builder stress out about that. And for a little bit of silkscreen, it's it is, you know, it'd be a little easy to fix that. Since you didn't order them. If you had already ordered them, I would say don't even bother. The board side has the outline, yeah. Morning, Mr. Ireland. If I can make another suggestion, Aecert, and don't let me influence you too much, but if I were you, I would promote the pre-order of the boards by making 5 or 10 of these boards with the gold contacts, like Inig, because and then say that you'll randomly send it to 5 of the pre-orders or 10 of the pre-orders. It might generate a little bit more hype, and then some people will be absolutely thrilled that they could potentially get that. Additionally, what you could do is you could just make a fancy version with the gold and sell it for a premium price, because it does cost a little bit more. But some people, you'll see, they're just going to buy your product to support you. And if they have a little something to go with it, like the fact that it's Inig, then they'll be happy about that. Just a thought. Yeah, this is becoming a dog's breakfast. Not enough coffee, I think. I have a kit with 2 boards. The other thing I would say, Aecert, since your boards are open source, people can just order it themselves with the Inig. So I would change the version. I would make a version, like let's say with your logo here on the back again, and make that the special edition one. So just order in small quantities. Because I see that you did a really good job here with the logo with the hazel on it. So that's what made me think of making the gold version. All right, so that's good. NRF, my nemesis, is in. I do think I'll have to move this around. We're gonna go on to the next one. People like How Come on to the next one by my old albums. Toggles are next. Oh, I should have read the instructions. Yeah, toggles, that seems very floopy. Toggles. So that probably is going to need a little bit of adjustment to get it in the case. They're going to go, do they sit flush? No. Not at all. Just going to flip this around. Yeah, this will be a lot of eyeball adjusting to get it straight. There we go. These are annoying. Yeah, that's fine. I'm all right with that. If you look at most of the commercial remote control transmitters, they have the switches are mounted to the case, and then they are wired in. Did I do that right? Yeah, I did. Right? Yeah. Yeah, you could do that. A 3D print. Voron does that a lot. They have a couple of adjustment or alignment prints. Oh, I'm soldering off camera. Hang on a minute. There is a bit of flexibility. There is a bit of flexibility though, so it's not too bad. But these, you can tell, like, these components are meant to be panel mounted. Same thing with this switch here, and that's why they don't sit properly on the PCB. It's because it doesn't matter how good you are at designing them. There is no footprint that would make them align properly. Like, that's not anything to say of Acert's design skills. That's just how the cookie crumbles with these kinds of switches. And unfortunately, if you want strong switches, because don't forget, there's like a 200-pound gorilla that's going to be actuating these switches all day, then you need these strong type of switches. You can't just use junk switches. You need something that's really made for a human interface. In there. Let's see if they match. I mean, they're I think you gave enough play in the holes. We're good. There we go. So just to follow up on my comment, the reason why these joysticks have the 4 metal case pins that you have to solder down, that's because it's a human interface. They know that you're going to be stressing the hell out of these things. You know, you're going to have a heated gamer session. So these anchors are there to ensure that you don't break the potentiometer solder joints. There we go. Okay, so that looks good. Do they still fit? I know I'm putting it upside down just because I'm checking the, yeah, it's aligned properly. So really, it would go this way. Yeah, that looks good. Look at that. It's got a transparent screen. Good. On to the next one. Okay. So bumper 1, bumper 2 on top and on bottom. So they are not polarized. This one is, though. Bottom. So the bottom one is polarized. These are not. Refresh the page. And whoop. Gyro, joystick, NRF. Oh yeah, so there's no more the letter markings. Revisionist. Okay, so there was something in the video about having to cant over the... Oh yeah, I can see. But you said it's not going to happen on our PCB. There was something about having to, you know, fit it underneath. I'll be the first one to test. What could go wrong? Yeah, so front and back bumpers. Oh, it's way over here now. Bumper 3 and bumper 1. So again, it makes sense to me that these would be on the front. So 1 and 3, hang on, is that what it says on the instructions? Yeah, 1 and 3, okay. And then 2 and 4. Okay, good. Got these nice JSTs. I'm gonna check the polarity of the battery one before I solder that on. Okay. So I want to put the lock on the outside. Switches are non-polarized unless they have LEDs inside. So this can go on any which way. My fat fingers are too fat to put it in there though. But that feels like it's going to be a tight fit, which is good. Not super tight. I'll have to do these one at a time. Oh. It's under the NRF. I can do this, but that's not a beginner-friendly. Okay, I'll have to be quick. Okay, let's do this. Got it. Not the ideal way to solder that, but there we go. That's done. That worked. Not ideal, but it worked. Okay, now the other one. The lock towards the outside. There's no reason these need to be so late in the game. They're not really in the way for anything. Where's my solder? Because I'm gonna have to be quick. Oh, that was not quick. Damn. I panicked. I had a panic at the disco. All right. This is going to be non-ideal. So I don't want to get the solder sucker out. Damn it. Solder sucker it is. Didn't used to matter, but I moved them. Yeah, well, I think, now Aecert didn't say this, but I think that's the point of sending me the kit, Because when you need to see if your instructions are idiot-proof, you have to send it to an idiot. There we go. By the way, link in the description, pre-order. And on top of that, I'm convincing Aecert to add some benefits for pre-orders, like PCBs with gold coatings. Oh. So get in on it. Well, that looks like poop. Don't use this method to hold parts. I use lead-free stuff. I'd melt those connectors, yeah. Lead is just... sucks that it's so toxic because it's such a phenomenal medium for soldering. All right, 2 more bumpers. And there's the battery one. So we'll do the bumpers first. Let's go locks inwards. I mean, there is another way. You can do the Big Clive way. So here, let me show you the Big Clive method. Mind you, Big Clive is way better at this than I am. But I am just as lazy as him when it comes to taking out helping hands and stuff. So basically, you holding your here. Let me. So you hold your solder like this in 2 fingers. Just align it so it's properly aligned, and then you just feed your solder in like that. So you can do that. Big Clive is the king of this stuff, though. But Big Clive is, I mean, he was making these PCB projects before YouTube. Like, he was doing this forever. I got inspired to do these things by YouTube. So there's a big difference between Big Clive and I. So yeah, here, trying to get the solder on. There we go. And that's holding, and then you just go do the other one. Oh, I heated it up too much. Ouch, my fingers. Get in there. Ouch. Yeah, I screwed that one up. Pins are coming out. They'll still plug. Whoop. Maybe they won't plug. Oh yeah, still plugs. Perfectly fine. Perfectly cromulent. All right, last one is our battery. So, well, here's another technique for you. You can just plug this in like that, and positive is this way, and then you can just hold the wires too. You don't have to burn. Ooh, that's a little bit of a tough one. Like so. Oh, might have to bail soon. Now we got it. Get in there. Hold up. There we go. So the wire works as a heat sink, keeping your stuff from melting. get in there. There we go. And are we still positive? Yeah. I would move that positive label out a little bit too, because it's very hard to see once the connector is on. It's like very hard to see. I'd grow it a little bit, make it bigger, and move it out a little bit. Okay, so that's done. We're almost done. There's only a couple things, like voltage divider here, 2 caps. What is this? Oh, the rotary encoder is not even on there yet. The order of the JST connectors are not correct. Already updated. Great. I mean, let me be clear. Any criticisms I have are constructive. This is a fantastic project. JST connector on bottom. Yep, consult the video if needed. That's a really good step, putting that there. Rotary encoder on top. Will do. Let me switch since I don't have a producer. There we go. All right, so like so. I will probably solder this from the front. Oh, nope, never mind, that's plastic there. So I'll solder it from the back. But I will start with the tabs. Problem with the tabs is you can't hold the component, because that's what the tabs are connected to. Okay, I'm just holding it tight to the board. And then the 3 signal pins. And then the switch pins. There we go. That's good. Let's make sure it works before you praise it. No, I mean, it's a good project no matter if it works or not. All right. Next one. 10 microfarad cap on the bottom. Make sure there's the correct orientation. This is very true. So that's one thing that beginners are not going to know, that the stripe is the negative. So it probably shows on your footprint, I'm guessing. Yeah, it shows on your footprint. And there's a little tiny positive, but they don't know that the strip is negative. That's something you need to look up. That's something we take for granted because we've worked with caps enough. 25 volt 10 UF. Like so. That's such a tiny cap. Look at that. Okay, we'll solder this bad boy in. Go, put that in the trash before it ends up in my socks. And then this guy here. curious, is this to stabilize the voltage on the Mega? Come on, get in there. Because I know you need a cap to stabilize the NRF. The NRF, when it starts transmitting, it has a very bursty voltage draw, current draw. So there's a voltage drop that happens to it. 10K on top and 10K is on the bottom. So there's two 10K resistors here. So let's confirm that these are 10K. Let's see. So we've got brown, red, black, black, brown. I think it's the other way. So brown, which is 1, black, black, 1, 0, 0, and red is 2 more zeros. So that's it, 10K. Give these a service loop. No service loop, they have to be folded tightly. I do want to put it in the same orientation. Like so. I'm going to solder these from the front as well, simply because you don't have to fight gravity. Can make sure they're in the right sort of position as well. And then come back here, solder them from the back. Like so. Oh, damn it. Sorry guys, I keep smashing into you. I literally have like that much space between the camera and the board. Okay, so that's good. We need 2 more 10Ks on the bottom right here. We will put the red towards the right. So, like so. Two, 3, and 4. Trim these guys off. That's good. All right, what's left? cut 2 JST connector males to about 2 inches long, strip the ends. Okay, 2 inches long. So that's 50 mils-ish. No, the pickups. Give me a second here. Oh, great. Some spam in my inbox. It's not even the delicious kind of spam. That's the sad part. Where do I put my phone so it doesn't get destroyed? Inside the Voron. All right, so roughly 2 inches. It's roughly 50 mils. Let's see. Oh, look at that. 2 inches, almost dead on. All right, so no, he said the wire, I think, right? So there we go. That's roughly 2 inches, and we're going to do it again, like so. And let me see, I guess I'll use these guys. So I'll probably use just very little stripping. What gauge is this wire? 26. Jeez. 26 gauge. They really didn't save. They didn't use a lot of copper. At least they are copper. I've seen wires now come with steel. 26, as small as this goes. So let's go 26. Just need a tiny bit stripped. Evacuate the strippers. That sounds funny, doesn't it? Evacuate the strippers. Your aunt used to make cabbage, potatoes, and spam. Haven't had it in decades. Interesting. I'd try it. You can read those calipers digitally. Yes, you can. In fact, mine is the old style that still has the door that you can open. And there's the contacts in there. Trying to get some light on it. Not working. Matthias Wandel did a good video on that. I'm not sure if he was the originator of that, but he certainly made a video. Matthias is good shit. I had a chat with him via email when I noticed that he was living in Ottawa, just by the places he was visiting. And we're talking about his Honda Fit he had at the time. I don't know if he still has it. He's a cool guy. This was before I had the podcast, or else I would have invited him on. I mean, I could still invite him on, but I don't know. He projects like a don't bother me sort of personality. I don't know if maybe I'm just reading too much into that, but I don't want to bother him. How about that? He does not watch this channel, guarantee. So, if he did, I would say come on the podcast. All right, so the common is over here, and the normally opened is in the middle. And we need to solder this. Now, this is going to be fiddly work. So let me see what I can muster up here. I do have a solution for that. Whether or not it'll work is a different story. I made these attachments. There we go. Ooh. The 3D printed base needs some work, but I definitely did make these attachments. Is this the Pet G one? Hope so. All right, so common is next to the hinge. Ugh. Come on, rotate. Man, these things are stiff. Okay. So let's pre-tin NO and C. Yeah. Let's pre-tin this. Let's pretend it didn't happen. Like so. And then we're going to solder there we go. And solder. Whoa. There we go. Should be good. Should be right. One done. Julian Eilert vibes. Julian was one of the inspirations for the channel. I was, as the British would say, chuffed to bits to have him as a guest on the podcast, as well as Big Clive. One of the inspirations of the channel has gone down to the dark side, so I haven't reached out to him, but he probably wouldn't come on the podcast anyways. There we go. Two types of those helping hands, never, yeah. Yeah, pain in the butt. Oh. I might have a break to make a coffee, but I also don't want to waste all of Acert's day him hanging out in the stream, you know? He's got stuff to do. There we go. We're at the 2-hour mark, but it hasn't been 2 hours since I started work on this. But it's close. Probably an hour and 45 minutes. All right, that's done. These are 2 pins. Oh, hang on a sec. Consider using heat shrink sleeves. Nah, I'm fine. Solder 2 times JST connector male. So this is 2. All right, well, we're at the heated insert part. So I'm gonna shut off the iron. He was the first electronics YouTubers I watched was Julian. Yep, definitely. Me too. And Big Clive. Well, good news, there was no pins in my coffee. So I've told the story. Let me put hold on. Let me put the let heat up some water, and I'll tell you when I get back how I found Clive and Julian Eilert at the start of my YouTubing, or before I started YouTubing. So, going to fill up my mug. Pop it in the microwave because I'm a savage like that. There we go. Head back to you guys. All right. While we wait for that, so I was, there we go. So I was watching YouTube, trying to remember what I used to watch back then. But then I started buying cheap stuff on eBay, or looking at cheap stuff on eBay at the very least, maybe not buying yet. And I came across these really big, like 100-watt LEDs. You know, like the big cobs, big boys. So I was like, oh man, I want to buy one, but they're like $10 or $8 or whatever it is. And I was like, there's everywhere on eBay. Someone must have tried them out to see if they're any good. So I looked it up, and then I saw Big Clive's video on the subject, and he tried it out and he explained how it worked and stuff like that. I was like, oh, this is cool. And then I saw Julian Eilert had a video for 100-watt LED as well, the 100-watt cob LED. He was powering it with power tool batteries. So I watched that video as well. So that's how I got started with electronics YouTubers. And then especially Julian for me, because my first interest was buying stuff off eBay for really, really cheap. I mean, I had bought stuff off eBay for cars before, but electronics was like new, right? Like, I was like, oh, like these LEDs, you could probably, I think I had an aquarium at the time, and I was thinking of using those 100-watt LEDs to light the aquariums and grow plants. And so that's what started it. So mostly it was Julian Eilert at the start. I used to watch AVE, but let's just say I had a fundamental disagreement with his philosophies, and I stopped watching him. Stopped watching him and asked YouTube to stop recommending his content. So, yeah. No regrets there. I would still love to sit down with him and, you know, talk to him. But I think, yeah, I think he was fundamentally wrong about something that he was very headstrong about. And he doesn't seem like he would change his mind. But I found him because he used to do Arduino stuff. So when I started like electronics stuff, you know, that's his stuff that I was watching. All right, I think the coffee is warm, so let me just get this out of the way, and then we can keep going. And of course, like, you guys are waiting, but you can still hear me. This was, by the way, this microphone, this was sent by a Patreon at the time. So really thankful for that, because you guys can follow me up here, and I don't have to abandon you completely. Now I have to close the Ziploc on this new sweetener I'm using, and that's like the worst part of this thing. The Ziploc, what crap. The Splenda things were so easy to use because they're, you just open a few packets, but this is like a bulk pack. There we go, and heading to you guys. Down the stairs. Try not to spill my coffee. And I am back. Let's see. It's going well. What did I miss? Well, we now have a Carney as Prime Minister. Who'da thunk? He's, we're not going to talk politics here, but if you look at his qualifications, I think you will see that if you want to get out of a financial economic problem, I would have him. Just like politics aside, just look at his qualifications. They are very good. Probably the most qualified a politician has been. Well, I wasn't really talking politics. All right, so what are we doing now? Yeah, we're doing the assembly instructions. So we're here. M3 heat set inserts, 6 in the case bottom, 4 in the case top. So let's take a look here. We need to skip ahead quite a bit because we're done soldering. So this, so far I've soldered 2 bumpers. Okay, yeah, so there's the, all right, so for that I have a tool. Oops, I'm gonna put that to the screen. Webcam. So, I don't know if this is still hot. Oh, this had unscrewed itself, interesting. I'm gonna pop this out. And pop this out. And then this is the tool in question. Up, up, up. Hang on, I just dropped that. Oh no. It fell into the abyss. And that would be a bad thing because that is the proper adapter that I need to use. That is the bad part about not being organized and having a bunch of crap everywhere. Oh, here it is. Whatever. Not the heated insert. I dropped the tool. So this is a little bit, and it goes inside of here, and it lets you push the insert in. So you put, this is the iron element, and then you put that on top, and then you put this guy on top, and then this guy on top. Gas iron? Nope. This is a 60D, and I think it's a Chinese clone of the Hakko 858D, the old one. So if you go look at Big Clive's old-ass videos, like probably from 10 years ago now, on which soldering iron to buy, you will very likely find a recommendation for a old Hakko clone, and that's exactly what this is. All right, so we're going to put the heat down to about 250. Should go probably a little bit lower, but PET G does need a bit of heat. We're going to move this to the side. Okay, so here are the inserts. So I have to say, my specific iron, I haven't seen like ever, except for that one time when I bought it. But it's a Sigma 60D. But it's basically a digital 858D clone. The tool from AliExpress. They're like literally like $4 or something like that. And it comes with a bunch of the bits. I should have the box around here somewhere to show you. Oh, here. So it comes with that adapter and all these bits for all the different size heatset inserts. Okay, here goes. And there we go. Maybe 250 is a bit high. You can drop that down a little bit. I'm gonna go 220. Okay, that's good. Let's put these in the sides. This will be a little harder to film. They don't have a flat that sits there. Drop that bad boy in there. And there we go. Make sure it's flush. Like so. And by the way, these are the good heatset inserts. They have the herringbone pattern. You can get them with just the straight pattern on them, and those are not for heat setting. Those are for injection molding. So these are the proper ones. See the herringbone pattern in there? The two the diagonal angles are different directions. That is the proper heatset insert to use. Jesus, these pins just keep showing up out of nowhere. Let me see if the monk fruit extract is proper. I put a lot in it this time. Hang on a sec. Yeah, I guess that's all right. I'm gonna miss my Splenda. Okay, that one. Okay, that's 6 in the bottom. Oop, I made all these wispies. I heated up some PET G a little too much. Okay, and now there should be these 4. 1, 2, 3, 4 in the very top. So you get 1 heat set extra in the kit, so you get 11 and you need 10. No Splenda, yeah, American product. There we go. And the reason I have a sugar replacement instead of sugar is because I have so many coffees during a day that it'd be like 1,000 calories of sugar for no good reason when the sugar replacement tastes the same to me. Not the same, but just as sweet. So I would be even fatter. Oh, some genuine cat hair. Time for corn whiskey. I don't I don't really drink, so that's not it's not a issue for me. Let's see how that looks. Ooh, something's not fitting right. Oh yeah, the switch is a little iffy. So the switch needs to lean forwards a bit. My switch doesn't quite fit. You actually spent money on gym equipment. Gym equipment's good for your health though. So it seems like my switch isn't quite fitting. I really should have checked it first, but it shouldn't be too bad. So it seems like it's leaning back a bit. But I mean, let's just see if we can clean up. Put the case, put it in the case bottom. Yeah, let me just trim up the fitment for the switch first. I just want to make sure that the switch will work. And the thing is, my 3D printers are not in a state of perfection. The 3D printer I used for this, because it has the 0.4 nozzle on, is not a high quality 3D printer, and it wasn't when it was new either. There we go. Perfect. So that looks good. That seems to fit well. We're going to try the back. So I don't know if it'll fit around the NRF. Oh, it does. Wow, that's a tight tolerance hole. Oh my God, you are brave. So then you get an idea what it's going to look like. Yeah, so I just had to clearance the hole a little bit for that. Wow. It looks good. It does look good. The antenna won't fit though. Yeah, it will not fit. So not only is it, I'll clearance the hole a bit because you can see the artifacting in there. So you can see not only is it not centered left and right, but it's also not centered up and down. So let me just see if I can force it in a little bit. I'm just gonna thread her in here. Do you usually thread in the antenna before you put it together? That doesn't fit. That's not going to go through. Ooh. Okay. Let me clearance the hole a little bit. Oh. We won't talk about what I just did. I just blew out a small chunk of the case. I think you have to screw it in after, yeah, but it won't screw in, it won't fit. So I'm just trying to, I knocked this. I knocked this capacitor over, so something is not fitting 100%. Okay, yeah, so it won't fit. Okay, so here's what I'll do. Ooh. I'm gonna need pliers for this. It won't go in. I can try. I'll try for you because I'm beta testing this. Okay, fit it over the tight fit there. There we go, that fits. So if you look, the threads, see how fat that is? Ooh. So the antenna is spinning, but not the threads. I don't know how to show you that. See, this whole thing is spinning, but not the threads there. It only goes in like just a touch. So I'm going to take this. I'm just going to heat it up and just give it a little bit of an adjustment. Might need more heat actually, since I'm actually desoldering. Let's go 3. It's probably lead-free. 390. Drop the air volume a little bit. That's definitely lead-free. Oh, can get her to twist now. I'm just going to give it a last little bit. Gonna let that cool. May have tweaked it a little bit too much. And that's on the other way. I think that should be good. Might be too much upwards now. I'm gonna try it. I'm gonna see if it works. Ouch, that burns. We'll adjust it if needed. It's friggin' hot right now though. Nothing much I can do. Turn off the soldering iron because we've got the heat sets done. Oh yeah, that definitely tastes different. It is what it is. At what point was I supposed to do the other bumper wires? Because I did 2 of them, but then the written instructions don't show. Oh, God damn it! Hate when this mouse falls asleep. Screen. This guy. Whoop. This guy. So there's 2. Four bumper caps of 4 bumper switches. Step 18. 10K resistors. Is this soldering? Soldering, yeah. So 18 is 2 10K resistors. Then here, 2. Oh, refresh. So that's still 2. There's 4 bumpers, no? So I think in the video you do all 4 at the same time. Okay, this doesn't burn me anymore. Let me just swap to there. Read it carefully. Okay, hold on. Cut 2, here, let me read. Cut 2 times JST connector male about 2 inches long and strip the ends. And then solder 2x JST connector male. Oh, and. Okay, so I skipped that step. You're right. You're right, you're right. Okay, yeah, I mean, this is an idiot test after all, right? So, what are we doing here? Oh yeah, let's check to see if she sits and she fits. It sits really well this way. Like really solid, that's good. Okay, let's put the front on. I fear I might have to put the front on every time first to get it past the switch here. Yeah, well, that's not too bad. Okay, that's good. Oh yeah, this looks like there's tons of room now. Actually, this looks downright centered. Yeah, it is a tight fit still though. Yep, there we go. It's in now. I'd like this hole bigger. But it does fit. You're going to see there's going to be a lot of variance in this connector. Ugh. Okay. All right, let's so we have one more to solder. One more switch to solder. So we need to switch this out. Ugh. Ouch. That's hot. For those watching at home, you do not need a special heat insert tool. You can just use your regular pointy tip and it'll work just fine. But they're like, the whole kit was like $4 Canadian or $5 Canadian. So it's a smoke 'em if you got 'em situation. The worst part of switching my kit though is I have to readjust how my chisel tip fits. All right, let's bring this up to 370. 2, 3, 370. I fluctuate on what temperature I use all the time. This here, while the soldering iron warms up, I will show you guys my custom. So this is a custom designed bracket. I actually would make these thicker. And then this lock line sits on it, and then I believe there's epoxy inside and then some hot glue. A through hole connector might be easier, no? A through hole connector. I'm trying to understand what you are saying. A through hole connector. Like for the antenna? All right, take these JSTs. These are pre-tinned, but they have probably lead-free solder on them. For the SMA, yeah. Yes, I would agree with that, but I think with the limited amount of space inside of the case, I would think the reason why it's just directly mounted is because the module comes with it mounted, and you don't have a lot of space on the case. That's my assumption. Because yeah, you do see like SMA style connectors, like this one here. So this is just panel mounted into the case of this module, but since the NRF already comes with the one soldered on, SMA is the is this connector. Actually, I believe that's an RPSMA, reverse polarity. So anyways, it's this connector. It's a coax connector. I've been looking up all that. I have to relearn all my drone stuff because the drone is coming. And now with the new ELRS protocols and stuff, I'm pretty excited because it's all open source now. Everything has turned into open source stuff, which is very cool. And in fact, you can build your own ELRS transmitter, which is incredibly cool, but it's all very, very complicated and not user friendly. So I am not looking forward to that part of it. But yeah, all the new drone stuff is incredible. Interrupt just comes. Oh yeah, I read that already. So yeah, if you guys want to embark on the journey with me, I am embarking. I am a licensed UAP or UAV on unmanned aerial vehicle. Yeah, UAV pilot now with Transport Canada. And I'm going to probably take my advanced course or test as well. That's going to be a lot of fun. I ordered a Mark IV frame. I believe it was actually a Mark IV full kit. Yeah, I'm curious what they use over there for their drones. But I do know that because of the conflict, larger drone motors, stronger and larger and faster drone motors, have started being manufactured en masse. So back when I was building drones, these were the go-to budget option. So these are 1806s. So I believe it's 18 mils diameter and 6 tall. But now you can get, for the same price that I paid back then for these, you can get 2211s. So 22, so they're much wider, and 11, so they're much taller. And for the same price as what these guys were back in like 2015. So I think that's pretty crazy. So I've got some coming. I don't know if they're 2211s, but they're 22 somethings. And then for the much bigger drones, they have 3111s. So, and all these things, I'm only limited to 25 kilograms with my license. So it's going to be a lot of fun to play with. And you know, video technology is better. So I'll be able to film with the GoPro and stuff like that. Let me unleash the properties, configure video. I'm gonna put the autofocus back on. Camera control, focus, auto, apply, okay. So yeah, should be pretty fun. I want to get confident at my drone skills and take some videos over water and stuff like that. It's going to be pretty fun. We can set up some dummy targets and drop some stuff on them too for fun. Okay, so assembly, touch. Oh yeah, so this is where it gets a little bit fiddly because we have to attach this guy onto here using this. So we're gonna have to get a screwdriver, elastics, cardboard, and one party favor. No, I don't like the things that go boom, but I do like drones. Oh, no, it's not a 0. Maybe it's a 1. Phillips 1. Is this a Phillips 2? Yeah, that's not a 1. Oh, wait. That was a 0. This is a 1. Yeah, okay. So, now, these go in like this, and these go in like this. Ugh. There we go. So we got to make sure not to over tighten these because they're just going into the PET G. Maybe I should have kept you guys up on the little, on the raised boxes because this is very small. Ugh. Your arthritis kicks in. If I get arthritis, I'm done for. I am a tradesperson, so if I can't use my hands anymore, I do not know how I would survive. Do you have any ideas on how to make this step easier? Yeah, I don't. So personally, I would have gone with the 18650 cell and a booster. There's no easy solution to this unless you pre-crimp ring terminals. Here, I bought a bunch of tiny little ring terminals. Ugh. It's not going to be fun for you though, but it's going to be easier for the end user. And in fact, I might just do it that way. Let me see if I can find it here. So the people that are always on the stream, they would have seen this. Is it these? These. Hold on, I think there might be even smaller than that. But I got like ring terminals to do an adapter. Oh, one fell into the abyss. Ugh. To make an adapter for a fish finder. Yeah, that's actually just the right size. So maybe we will do that. But essentially, you would crimp this onto the end of your your wires here, and then you would just trap it underneath the screw there. So I will warn you though, they are not fun to crimp. You do need some decent tools, and even so, they still require practice. So these iWis, I think these are the 2820M. So if you look, this is a multi-step process. You've got a big wing, got a big wing and a small wing. The small wing crimps on the wire, the big wing crimps onto the insulation. So you would find your correct crimp terminal. Let's try the 1.9. Then you would slide your wire in. You might want to get a little bit more exposed wire. It's up to you. And I really can't see anything. Am I off camera? Probably off camera. Yeah, so these terminals are not proper. Whoa. These, these terminals, they're for a little bit thicker wire than this 26 gauge. But they should work anyways. Just low current stuff. Okay, so squish that in there. They knackered the terminal a little bit. So then you look at this. So that's crimped onto the bare portion of the wire. And then I'll probably need the other ones to crimp down these wings. And these wings just are mechanical stability. So this one is the 2412M. Don't think I'm going to update the kit because requiring crimpers isn't something I want to do. Yeah, no, this, I would say this would be something that you would do. And you probably don't want to do it because it is time consuming. This is something like you would give your customers a pre-crimped, there, pre-crimped wire. So one of the JSTs would be pre-crimped, but honestly, that is just going to take an eternity to do. And you need the two IWIS crimpers, and you have to buy a set of these. It's like you said, requiring crimpers doesn't make sense. But like if you have to add another 10 minutes of labor per kit, that's going to become more expensive. And you have to add a little bit of fudge factor because it's not, until you're well practiced, crimping with these kinds of like small crimps is not ideal. It's not easy. Problem, we do this all the time in automotive, but the issue is the pins that we use, they cost like $10 a pin. So you cannot get it wrong, and yet still sometimes we do. You'll get like some crazy Bosch pin for a BMW, it'll be like $30. And then you need the specific Bosch crimper. That one looks a little bit better. There we go. So you see it actually like crushed the loop a little bit, but other than that, this is a good crimp. I'm a big fan of crimps, but it's definitely not for everyone. You should probably put a plus and a minus in the case there so we can see. I'll go to the video though. I think you said it. Looks like you have the high quality silicone leads. So black to the left. Black to the left. Is on the door. Oh, yeah, you're right. It is on the door. Of course it's on the door. By the way, for those watching, do not print your door out of PLA. You need this to flex. So it has to be PETG. I do have a PLA door, and this is how much effort it was to pull it out of there. It got stuck. Okay, so positives on that side. Now where's my screwdriver? We did a detour through the ring terminals. Positive up. I'm gonna give this a little bit of a tweak as well. Now, mind you, I don't have a Bamboo Labs, and my Voron is not tuned yet. So some of that could be me, like the fact that my printer is not high quality. But I mean, it is good also to see a non-Bamboo Labs print. I think we've just about seen enough of Bamboo Labs stuff. Can't wait to see how Creality does with their new their Bamboo Labs competitor. I hope it's good. We need more competition in this space always. I don't think I'd be a fan of like the race to zero, right? I don't want it to be like super cheap, but $350 USD, if it's any good, that printer is going to be nuts. So sorry, Robertson did not get. Robertson is the real screwdriver of champions. I'm gonna just drop this down like that. Robertson is the undisputed champion of screwdrivers. God, Robertsons are good. Mind you, I don't mind Torx. Torx works pretty well too. But Robertson is pretty damn good. Phillips is, actually a lot of people don't know this, but Phillips screws were meant for manufacturing. Meaning when enough torque was applied to them, they were meant to cam out. They were meant to slip so that you didn't destroy on the factory floor, you didn't destroy all of your components. So they were meant to be crappy. And so I always find that funny that it became the preferred choice when it was like designed to be shit. If you should eat without me, what time is it? 11? Are you going somewhere today? Like, do you need to eat by a certain time? Because I'm trying to get this done. JST, do you mean JIS? You're leaving at 2:20, at 12:20. Shit. I would say eat without me. Just, I don't know, like I could be done on time, but I don't know. All right, so this is done. So positives on the correct side, that's good. What's next? Screen. Yeah, JIS is the superior, but the problem with JIS is it's hard for the average person to identify. Oh, are we there? Oh, wait, the screen is there. Oh, this is a first test. Okay. Gotcha. So I have a battery. Oh. Uh-oh. Oh, hold on. You guys can't see this. So this, it just occurred to me that this battery can go in any direction. So you really have to be careful. Positives over here. All right, so let's see if this guy fits. Again, my 3D printer is not like super good tolerances. Oh my God, that's not going to plan. Ugh. Okay, we're gonna put it in, but it's not gonna come out. Ugh. Yeah, that's not coming out of there. There we go. Permanent battery. So I did make sure that this and this were printed on the same machine. Oh no. It's making all sorts of snapping noises. Oh. Yeah, so I would say that the tolerances have to be pretty exact. You kind of have to have a Bamboo Labs to get that to fit. That's a bit tight tolerance. Okay, so we're gonna find the screen. Here's the screen. We're gonna find the board. Here's the board. There are some screen spacers that I have printed. Where are my screen spacers? One there. One there. Actually, this will be a good test as to if my Voron is calibrated properly or not. Oh, it is not. Oh, it's tight. So I think my Voron is what's printing slightly large. Although it fits in there properly. Screen spacers. Supports for the case bottom. Yes. I used tree supports. I printed, here's the PLA one I showed you had no supports though. But this PTG one does. All right, so let's peel the screen protector. What are you making? How's it going, Ian? I am making an Aecert Robotics radio transmitter, and in fact, you'll see it assembled very shortly. That's on the off. Positive to positive. Okay, no smoke. No smoke yet. Okay, that sits there properly. Here we go. On. On. So the other thing I was worried is that your batteries are not 9-volt batteries. They're pretty special, so they have higher current capabilities than a regular carbon zinc. Like the Arduino has power though. Oh, actually, the other thing is you really shouldn't turn on these NRF modules without their antenna. That can fry them. Okay. So buttons on my underwear. All right, so we definitely have power to the Arduino. It's got power and it's doing stuff. It is flashing. So that's good. Capacitors are on the correct way. Okay, let me just flex the board a little bit. Okay. Just seeing if anything. So nothing to the screen. Let's grab a multimeter and let's check. Thou shalt check voltages. Okay, place this in a place where you're going to see it. Okay, let's start over here. Don't know if we... Oh, VCC is right next to ground. Okay, let's do first things first. Does my 9-volt battery have 9 volts? 4.5 volts. So my 9-volt battery is being drained down to nothing, which means it has high internal resistance. Yeah. No, it's possible. It's possible that your rechargeable 9 volts don't have as much voltage sag. I don't have any lithium 9 volts, but let me see what I got. I don't mind also running it via external power. This guy. All right, let's see. Well, hang on. Before we go too far. 7.4, 9.44. So this battery is stronger. Let's just eliminate variables before we go too far. Because it is possible that because there's a significant current draw in this project, it's possible that you need rechargeable 9 volts and not regular carbon zinc ones. All right, let's see. There we go. So that tells me that this 9 volt is not going to last very long. It's calibrating gyro. I don't know how long it's going to take to calibrate. Again, let me check the voltage. It's possible that we got a voltage drop and I need a lithium. Yeah, look at that. 7 volts. Yeah, should only take 1 second. Yeah, that's... I think I may have to run to the store later on and grab a high discharge rate. It's because 9 volt batteries usually can't support too much current draw. And there might be just at the start when you turn it on, might be a lot of draw. Okay, well, I mean, we'll find out. Get out of there, like so, and then let me plug in VSET 9, enter, Aecert 1 amp, enter, Aecert 1, enter. This will either work. Oh shit! Keep punching things. Appears to be working. I think it's a code bug. Hang on. I'm gonna see if because the voltage regulator in the Mega could be browning out. All right. Let's see. Because I'm assuming you're using the onboard 5 volt. Here, let's give that a shot. Calibrating gyro. You're drawing 90 milliamps, 0.8 watts. So the other thing is I might need to check the soldering on the gyro. These have to be in like a rest position. Gyro may be messed up. Looking at the code now. Okay. Take your time. I'll be over here. I'm just gonna unplug this. Oh. Okay, so let me take a look at this. So I'm gonna check the soldering on both sides of the PCB. You know what? I'm gonna touch up the soldering on both sides of the PCB. I'm just gonna make sure that the gyro is well soldered in. Because although you're panicking because you think you did something wrong, one of my 2 most favorite electronics YouTubers. Well, thank you so much. That means a lot. Unless you were talking to Aecert, in which case that probably means a lot to him. It's about 1 watt that it's drawing. About 90 or so milliamps. Yeah, about 100 milliamps. Code is fine, but the code shouldn't freeze if the gyro doesn't work. Okay. But look, there's all these pins I soldered too. So it could be any of these. By the way, it looks like the Voron is printing just fine because these spacers fit pretty much exact. Oh, I missed a pin. This 10K may not be soldered. Seems like the solder didn't flow all the way through. We'll just reflow these. Spacers should be loose. Oh, okay. Whoopsies. Well, they're nice friction fit now. All right, so let's put this bad boy back on. Like so. And then this bad boy back on. Off. Let me put back positive. This bad boy back on. Okay, let's see. Reticulating splines. Yeah, it seems to be stuck there. Code is updated. Oh no. You're going to make me do the Platformio stuff, huh? Your Java just doesn't work. Well, I'm going to try. My soldering iron's warm, so I'm just going to try running over these solder joints once more. And we'll give this one last shot. In fact, I'll do it without the battery. You can definitely finish. Okay. Okay, and then this guy to here. This guy to here. So that's on. So it's drawing 0.8 watts. And yeah, we're not getting any gyro calibration. All right, let's continue with the assembly. Like so. Ooh. Whatever 9-volt battery you put in there is pretty much going to be in there permanently. All right, so this guy, positive to positive, like so. Now I need to install these switches. Is that the short switch or the long switch? Now that's the question. Three and 4. Let me just move these iWis pliers out of the way to be put away later on while I listen to my podcast. Oh, actually, tonight I have to record a podcast. Shit. Patreon.com/SimpleElectronics if you guys want to hear that early. Okay, let's go find out That's the test. Oops, I'm going to put you on the screen. Oh yeah, I got to put the bumpers on. Oh yeah. Okay. Long ones. Put the bumpers. Yeah, yeah. Might need some glue. I just want to see which ones go where. Looks like the long ones go in the back. Okay. So here's my bumpers. I had to print them yesterday. Deal with that text a little bit later on. So see, I printed a whole bunch of them. So for some reason, the Voron and the Elegoo Neptune 4, PLA is not sticking anymore. Even after washing with dish soap. So usually a small part like that, I would be able to just leave the raw PLA on the build plate and it would stick, but now it stops sticking. I have heard that like oils from Pet G will ruin the adhesion of PLA, but it's not it. Printing will print holes too small. We'll see. Okay, so let's see. It's a little tight. How far does it need to go? That's not far enough, isn't it? Oh, I slid it in some more. How's that look? It's like nearly flush to the back. Perfect, or does it need to go a little bit further? Looks great. Okay, good. So that's another thing you may want to consider is that not everyone's going to have a Bamboo Labs. I do know that it's the latest and greatest, but for me, I mean, that's a lot of money for a Bamboo Labs. The Bamboo Labs X1C cost as much as I paid for my last car. Mind you, used cars have gone up in price as well, but yeah. But then again, people can get these things printed from PCBWay or whatever. So there is that as well. But then I wouldn't know, like, how else you would design this. A1 Mini. Yeah, that's true. Come on, get in there. Yeah, this is not a good experience for sure. I definitely want to tune the Voron a little bit. So that's good to know that because like I've just been leaving it because it prints just fine. There we go. But now it's good to know that I should probably tune it. Okay, so now these tiny little screws are going to go towards, so these have to fit in there. Oh God, I don't know. Might need to clearance the holes a little bit. So these, yeah. So that's much too wide. So we're gonna have to clearance the holes a little bit. So this one was printed with support, but we do know that the Voron prints slightly big. But even support is not perfect. Overhangs are just difficult for like uber tuned printers, you know. This is too big for my Voron anyways. I would have just printed everything on the Voron. It's printing holes too tight. That said, yeah, this is not printed on the Voron. This is printed on that Chinesium machine. Because the Voron's build plate is this Voron remote. It's a transitional Voron. Yep. That's it. 120 mils by 120 mils. But that, you know what, just cleaning up that hole made all the difference. So I think we're good. What size is the A1 Mini print? Is it much bigger than 120 mils? Ugh. Non-magnetic screws. The bane of my existence. $180. Okay, that's so that's the size of a Voron Micron. Another good option for non-Bamboo Lab high quality printer. Prusa Mini. How big is the Prusa Mini's build volume? So I could have trimmed a little bit more this way, but it is working. It's not sticking, but it definitely has like a mushy feel because it has no max travel limit, but it is working. Prusa Mini, oh, also 180 by 180, okay. Number 2. So we've been here for 3.5 hours. Folks. Oh, damn it. freaking screws. So we've probably been working on this for just about 3 hours, 3 1/4. Yeah, but I mean, that could be my fault too, though. These are very fiddly bits, though, doing this part. Magnetic screws would be nice, but I don't think you're quite in control because I don't think that's a listed property of cheap screws. That one needs to be. This one doesn't click at all. What is going on? I'm gonna have to clean these holes up. Oh yeah, I mean, this is normal. This is maker stuff. Like it is what it is, and like any time you have 3D printers with unknown calibrations, you might run into tolerance stacking. Okay, so this works. So you probably need to shave this down a little bit. Now I think for the most part, it's going to be normal that most people will print all the parts on one printer. I just happen to print the parts on 2 different printers because my Voron is my printer of choice, and the case was too big to fit it. Shaving the bumper on that flat side is the best bet. Don't cut yourself. Well, I mean, if I do, it's live. So there's that. I also have a kit of these guys. I think it has to do with the elephant's foot too. Since I was trying to tune the Z offset to stick better, because for whatever reason the build plate doesn't stick anymore, and as much as I clean it with alcohol every time and dish soap, I still need to clearance this too. Chaos. And look at all the old men who do the model building. Those guys, they have to clearance every single friggin' part. I don't know how they do it. They cut them out of the plastic trays, and then every part has to be clearanced and fit custom. If you ever do a V2 of this, though, I think it would be really cool if the bumpers were just a flexure to give you a new challenge. This isn't fitting at all. Not getting a click at all. Something is preventing it. So now I'm thinking it's probably fouling on the mount here, where it mounts to the switch. This clicks. Let me see. Since this part is inside anyways. Don't need these corners. Clearancing. TSP. Oh, it's actually, it's knocking on the switch frame. I don't know what TSP is. Oh, there, it's working now. Yeah, it was knocking on the actual frame of the switch. Ouch. Trisodium phosphate degreaser. Oh, is there a brand name I can look up for that? Because I've tried dish soap, which is the recommended method, and it doesn't stick. In fact, the build plate is like duller. Still not working. It's like mounting the switch crooked. Oh. Works now. Had to crank her down. It's definitely... Yeah, I think it's fouling on the actual case of the micro switch. If it gets out of its groove, to pull it upwards. I don't think that's a U problem. I think that's a Voron problem. My problem. I think the Voron just needs to be calibrated, that's all. Should be pressed quite smoothly. May need to reprint these. Yeah, it's possible. That's better. All right, clearanced. Next, I think next I can attach the two case halves, which is good. So I will tell you though, this battery door, the battery door and the case, they were printed on the same machine, on that cheap Chinesium one. So I think these are very, very tight tolerances, which I think you would need a high-end machine to reach. I'd be curious if you have an A1 Mini, try it on the A1 Mini, see if it works. All right, so let's connect these up. There. There. And there. Please fix that door. Okay, and then, oh, this needs to go this way. Ooh, yeah, that's tight in there. There we go. So that's in there. Something's not sitting super flush. Okay. Are there holes in the top of this? Because the Voron didn't print any holes there. Screen is secured by the, okay. Because I saw the screw holes. All right, next, I'm assuming we need to do the top case. But that's just the top layer. I guess I need to stop quoting problematic wrappers, huh? Okay, so that guy there. This will be much easier to install. So let's pre-clearance these guys. Screw the PCB in. Oh yeah, good call. Let's do that now. This is quite, it's hefty. There's a lot of chonk in here. I like it. I think I'll like it better when the grips are on too. So these guys, and now we should have, these should be the M3 screws. These are probably, they'd probably be button head screws, because these countersink screws are a little weird to screw into a PCB, but they will center a little bit better. I think my wife just went for a walk, which is interesting. We usually walk together. Oh, I guess it would be underneath the LCD. Ugh. The LCD's nuts. Got him. Not too tight. Don't want to flex the board. Where's the other one? Oh, up there. Oh, can't see it. This is quite the little assembly. There we go. You guys can't see that. Okay, good, that's in. Put the LCD back in. Excellent. All right, let's put this where it won't get destroyed. So in the Voron. All right, yeah, clearancing now. So I'm just gonna take the brim off of this. Cut a little bit of the thickness away too. And we're gonna give it a little shave all around. Install this bad boy on there. Ooh, that's quite the tight fit. This bad boy in there. We're almost done, folks. The big challenge will be to get the purple grips installed, because the Voron, actually all of the caps too, I didn't have a contingency plan for if it didn't work, because the Voron seems to be printing too fatly. Heat gun will come in handy. Yeah, that's only if I'm okay with it being a one-way trip. There we go. I'd love to not have to clearance these, but that's what I get. I've built the Voron like a year ago now, and I still haven't done all the calibrations. That's what's nice about a Bamboo Labs. It just works out of the box. You don't need to do anything. But the Voron, it's all up to you. So you gotta fix it. You gotta tune it. You gotta calibrate it. And we all know how software is not my forte. Yeah, so that's why I'm excited to see what Elegoo did with their $350 Core XY. Because there's like, I have the Neptune 4, and on paper it's a really good printer, but there's just things that like it's not working well on it. Like the build plate adhesion is bad, and the thing is, that's a 420 by 420 bed. I think it's actually a little bit bigger, 480 by 480. So like to buy another build plate is like $100. And so yes, oh, that's bad, I dropped the screw. And so yes, it's an inexpensive printer, but in principle a build plate is consumable. So yeah, you bought an inexpensive printer, but then if you have to buy a $100 build plate every couple hundred hours, that's expensive. And actually, I don't even know what's wrong with it, because I've tried flipping it around. Mind you, the other side is smooth and not textured, but the other side doesn't work as much as the first side. So yeah, not fantastic. Yeah, I feel like that screw may have gone into the void, folks. That is a tiny screw to find on a gray carpet filled with other components. Like I just found a transistor. I probably lost a year ago. Well, that's okay. I think I'll just use the one screw. And we'll move on. Oh, I found it. What are the friggin' odds? Ugh. If you're gonna lose a screw, this is the one to lose. This is the only one you didn't send an extra of. All right, here we go. Oh yeah, there. The case needs to be deeper to keep it in orientation, I think. You're 2 for 2. I know. What the hell's going on? 2 for 2 in the void. I was looking for where I had put the top. Now this might be a challenge because of the fact that here, I'll do it in iPhone style, like a sandwich. If Vero was listening, she would be cringing right now because she hates sandwiches. All right, 1. And then most of you will probably hate iPhones as well. So there's that. 2. And how do you tuck this? I guess you just give her the tuck. This moment of truth, the PCB has the top bumper plugs. Oh yeah, true. So I will say that these wires are not the greatest. They are very cheap, which is fine. If I were doing this as a hobbyist for fun, like building a Voron for fun, I would just crimp my own on silicone wire. Because these wires, they do not rest. They don't sit around properly. They're getting stuck. Okay, let's see if we can shove them onto the front. The wires are getting... Oh no, wait, might just be my switch. Oh, we got her. Oh. Yeah, this one needs to be clearanced a bit more. Not bad. Yeah, this one definitely needs to be clearanced a bit more. I can see the thickening where it's happened here. Okay, so these are going to have to be reprinted, but that's okay. Now the interesting thing about this design, well, another one of the interesting parts, is there's no screws holding the two halves together. What holds them is that the grips go on the side here, and then screws go through the grips. Now these are the grips printed on this, but I didn't want to use these grips. I wanted to use these grips. Hang on. Yeah, and I don't think they're gonna fit. So I am going to take a couple minutes to try to clearance them, because I think that looks so much better with the colored grips. But I don't think they're going to work. Yeah, I think, you know what? I think I'll be at this for way too long. And I'm going to damage the finish on the front. That is sad because I really wanted purple grips. I can always remake them. Oh, you know what? Yeah, they are going in. Ugh. The only thing is I don't want to ruin this to a point where it won't go together. Because poor Aecert has been waiting this whole time for me to get this done. Oh, it's so close. Also, it feels like if this goes together, it's a one-way trip. Oh. Okay, fine. I'll put the black grips. I have to tune the Voron and remake this. See how much better that fits. Did you guys notice that I stole Acert's photo for my thumbnail? I just changed the switches and the caps to be purple. Literally had to Google how to do it and then found it. 2, 3, 4. Well, I told you, so there was that. I told you on stream. But yeah, you probably would have noticed anyways, because it's your images. I figured the project was open source enough. I could artistically borrow the the thumbnail image. Okay, I'm gonna put all 8 in here loosely, and then we're gonna cinch them all down. Very well thought of design, I have to say, because of the ramps on the side. So if I pick up the other one, where'd it go? Damn it, oh, here. So if you can see the sides, they're 45s so that a 3D printer can print it without support. So well thought of. And on top of that, it kind of squeezes it all together. Missing the screw stuck to the magnets on my case. Oh, the other question is, will the springs fit? Because these are quite a tight tolerance too. That's not grabbing. This might be slightly off. There we go. I'm going to tighten this in a cross pattern. Really happy with the handle design. The case used to have screws on the back as well. Got rid of them. Yeah, fair enough. I really do think this would look a lot better. I might put the purple PLA into this 3D printer, into the Chinesium 3D printer, just to get the grips printed in there, because I think because of the different orientation that the prints are sitting on the bed, I think it would look a lot better with an accent color instead of a instead of using the same color. Because the layer lines go different ways. There we go. So 1, 2, 3, 4, those all work. That works. It's looking pretty good, I have to say. If I turn it on, it's going to turn on because that 9 volt is in there. I'm going to put the antenna in because why not? I swear I just saw it. Oh, here. But it is definitely, you can tell that Aecert has a good quality 3D printer, because these are pretty tight tolerances. I would say your 3D printer has to be kind of Johnny on the spot in order for it to work. Okay, so these, I don't remember which is which. I think that's the joysticks. Do they have a concave? They do not. Oh boy. There we go, that fits. Ooh, they feel awesome. You know what? With the weight of this thing too, this is great. I think I would bring this out a bit and use 18650s, but this is, I think you nailed the ergonomics. So that's good. All right, let's try the pot caps. Now you say they're going to need hot glue. Now my question is, do the pot caps, do they recess into the case? If they need to go inside there, they ain't gonna go. Actually, this is perfect. And they're a press fit. So I think we're good. Joysticks. No, the joysticks need hot glue. These pot caps will cause you trouble though. I don't know. This cap might be too tight. Oh yeah. The encoder cap is too tight. This is the encoder, right? Yep, the pots pots spin. They don't go into the case though. So this one's a bit tight. These encoders are pretty tough. Okay, yeah. So these don't go into the case. But, so they just touch the case, but they don't, I mean, it's working. Even the center detent, I can feel it. So they're a little bit more proud, more high up than you expected. Here is the other pot cap. Yeah, you know what, I don't want to glue these things in. And the simple reason is because I might update. Oh, wow, that one doesn't fit well. Let's see. So this pot seems to be a little off. Oh, I see. This one, did it go into the case? I think this one did go into the case, and this one is not. Yeah. Okay. Let me. Ugh. So yeah, I do plan on updating these things when the parts will fit better. Yeah, this one might go in further. Nope, that's as far as she goes. I might actually just put them onto the put this PLA Pro onto the Chinesium printer and rerun the job. It's good to know though that the Voron really should be tuned. There we go. That one's stiff though. So I don't know if it's the front case I need to clearance. Because the pot isn't sitting exactly in the center there either. Ooh, that's not easy to get around there. Yeah, so tight tolerances here. Ugh. This is not bad, but now I can't feel the center detent. This one I can. Well, the finish is not great anyways, if you can see. So, all right, here's the real question. Are these little guys going to fit? These are tiny prints. Like, look at this stuff. So fragile, tiny little guys. These definitely need to be PETG. I know because here's PLA Pro. See, it's just destroyed. So yeah, these don't fit. They need to be toleranced. Ugh. Oh, God. That's embarrassing. Almost scratched this freaking screen. They're designed to be smushed in. I did stop watching your video, I must say, or even reading the instructions. Okay, smushing it is. Ooh. Ugh. I'm just making the hole become oblong. Do you have a preferred tool for this? Again, these things could be flexures. You probably tried though. Blunt object. Those are legal in Canada. Yeah, I don't know. know, dude. Let's see. Hole might be too small, yeah. I don't know. Just gonna try to gently push it in there. I have a few of these springs I can break before we run out. Oh, oh, I just borked it. Borked. I don't know, man. I don't feel like this is the strat. Sorry, you won't see anything until I break it. No. Not with that much force. Heat gun will warp that little tiny there's no way. There's yeah. I don't know about this. Okay. What do we do? The other thing is I don't know if the button will even fit inside the spring. Also, these springs, they print really quickly, so I can whip up a couple more. So this is a 0.4 mil nozzle, but I might have to like drop the flow down. Either dig the hole out a bit or soften the case top of the heat gun. Yeah. Oh, Jesus. Okay, that forced in. That was a lot of force, though. Wow. Not sure this is as the design intended. I think you might need to buy yourself a crappy printer to see how the other people live. Oh, the problem is if it slips, it's going down the hole. And if it goes down the hole, it's taking the spring with it. Ugh. That popped the other side out now. Yeah, that's not working. And these buttons are not going to fit in there anyways. Heat gunning the, yeah, case top, sure. I don't know which one I tried and which one I didn't. Okay, this one I didn't try. For sure. As you said, though, these things are super quick, yeah. Ouch, ouch. Well, the spring just turned to mush. Yeah, I know. So if I make them slightly smaller, like if I print them at like 95%, that might work. And like they are a chore to pop off the heat plate too. I wish the gyro would calibrate though. Yeah, still no calibration. Okay. All right, let's see. I'll open up Cura and we'll print Cura. Just catching up on Discord while all right, Cura took forever to open as usual. Screen. All right. So, oh, I have to send you to the naughty chair for a second. 3D prints. Whoop, not there. There, there, there. Screen. And then button spring. All right, so this, let's flip her around to there. Let's make sure. PETG, material, travel. Oh wait, I'm gonna go heat up the 3D printer too. Bed adhesion, skirt. Okay, that's good. Multiply selected. I don't know. 10 of them. Arrange all models. Oh wait, no, I made a mistake. Okay, hang on. Let me turn on the 3D printer, for God's sake. Ugh. The fan is screwing up. All right. Let's try that again. Button spring, 1. This guy down. Scale. What? Oh, scale. Let's go sort of like 95. It'll stretch the arms out a little bit. Spring is fun. Actually, let's undo that. And let's just shrink XY. So it'll be 95 and 95. Okay, that's good. So the Z height will remain the same. Yeah. And then let's multiply, add 10 of those, arrange all models, slice it. Let me, 8 minutes. Yeah, but it's going to take more than that just to heat up the frickin' build plate to 80. Tool, preheat, 80. All right. Make sure, yeah, good. Save to removable drive. Eject. All right. So now we wait. It's gonna take like 10 minutes to get to the point of printing. Like this. Printing handle. Did it not? Hang on. I'm going to name it something easier. Print. Save to removable drive. Eject. Upload the new code. Yeah, I can try that. Let me just set this printing first. Oh, I moved things and now I can't get to my printer. Oh, I need a bigger space. Printing. Confirm. All right, so it's going now. Let's do the Platformio stuff. I'm so scared. Can you send the link here? Let me make you moderator. Add as moderator. Standard. Save. Can you link me to the code, por favor? That, and I'm gonna open VS Code, and then I'll bring you guys here. Okay. And I'll bring you guys to the screen. How's it going, Io? Yo. Okay, so let's open this into here. Okay, code simple. Oh, no longer, nice. No longer freezes if gyro doesn't work. Okay, so take this, download. Uh-oh. How the hell do you GitHub again? I thought you could just download a zip path. Uh-oh. Oh, wait. Yeah, I don't know. How do you code simple? Did I ever tell you how much I hate GitHub? Can only download the zip at the top level. At the top level. Here? Code, download zip. Oh, desktop, save. One download in progress. I only have gigabit and a half. Oh my God. Half a gig. Scary. Okay, let's okay. Platformio. Open. Desktop. Yes. Code. Code simple. How do you, what do you open from here? Open. What do you select? Is it the Platformio ini? The include the folder. Just open this. Open. Nope. Oh wait, open folder. You nub. Code simple. Went through the visual code. Platformio. This? I think it's working. Here? This thing? View. Can I just increase the size? View appearance. Think it worked? Yeah, I think so. Okay, so I know somewhere now I have to select what I'm using, right? Give me a second. I'm going to throw you over there for a second. Clicking the ant. Oh. But I'm in the ant. See, PO home. And then somewhere in here I have to select a port. Control scroll wheel. Nope, it doesn't work for increasing size. Auto. Test port. Okay, I'm just going to plug it in and see what happens. How about that? How about we just do that? True, pretty sure port is auto. Okay. Because I looked up the tutorial as you had suggested, and they said I had to pick a platform and pick a port. But perhaps you already went through the steps. I'm not sure. Okay, plugging this bad boy in. Okay. And then should be able to just upload. Let's see what it does. It's doing something. Look at me, I'm a hacker. Look at all my hacking. Failed. COM8, permission error, access is denied. Here, let's see if here. COM8. Upload. Do I have to put it in programming mode? Also, do I have to go build first or just upload? I'm gonna try again. It definitely sees there's a CH340 in port 8. Failed. Terminated. Access is denied. Let's change the environment. I may have to switch the environment myself. Let's see if that works. Build. Let's build it first. Okay, and now upload. Maybe I had to select the environment. No, denied. Failed. Let me unplug it. And what do we have for port now? Nothing. I plug it. Yeah, so it's definitely this port, port 8. The environment, sure. Build. Try different USB port? Sure. Okay, let's see. What do we got now? COM9. And build. Oops, I meant upload. It's already built. Oh, I trashed something. Oh no, I don't know what I did. Why do they make a UI where the buttons move? Upload. Failed. COM9. Terminated with exit code 1. Permission error. Access is denied. Okay, so maybe we have to search perplexity.ai. I have an Arduino Mega project that was sent to me, and I need to use platform Yo2 in VS Code to upload to it. I have his whole GitHub repo thing. I have the project open in Platformio. I have the correct COM port selected. The ATT AT Mega 2560 platform selected, and when I hit upload, it just says that there just says, hold on, let me copy paste. There. Close any other application may be using COM port, including Arduino IDE. It's not on. Any serial monitor is not on. Restart your computer. In your Platformio INI. I love how they say a common issue with Platformio. Okay, so wait, what did it say to do? In the, okay, copy. Where do I put that? Here? Where? Where would I put the upload protocol? Okay, in the environment. Okay, okay. See, see, I just need people to dumb this shit down for me. Save. Oh, oh my God, what's happened? Look, I'm such a hacker. Look at how hacking I'm doing. Enhance, enhance, enhance. Oh my God, it's working. It's freaking working. That is crazy. That is AI for the win. Perplexity is my favorite AI. Terminal will be reused by tasks. Okay, let me. Oh. Okay, let's bring you guys back here. Webcam. All right, here goes. Calibrating gyro. We're all waiting. No worky. That one's stiff. Nothing. Still stuck at calibrating gyro. Oh, I think my 9 volt gave up the ghost. Does the 9-volt power anything other than the Arduino? Yeah, that's not getting out of there. Because if the Arduino doesn't power anything other than the Arduino, I can just power it by USB. No go. It is not interested in playing nice today. You know what though? The thing is, when you put together, like, this is my automotive diagnostic skills. When you put something like this together, I would... Jesus Christ. Yeah, maybe this case is a one-time use. I wouldn't jump through hoops before taking a very close look at the soldering. Like, I know you're sitting at home and you're thinking this is your problem. But the truth is, it could totally not be. Like, I think that's just as likely or more likely that the problem is on the end user side. What's happening is the gyro text is playing and then it's freezing. The gyro is not the issue, okay? But we don't know if the controller is freezing. We only know that... Okay, this is a problem now. Because these are like stuck on there. And that front case can't come off of the PCB because the PCB is screwed to the back case. That's why we don't use glue. But I thought you said you might need glue. I thought that's what you said. So these will come up, the joysticks only. Oh, I see. And the joysticks have tons of room. Although you will see that some people are joystick thumbers, and they will want a big open joystick. Oh, come on. Another screw to the abyss. Let me find it while I have the mental capacity still. Problem is I didn't see this one fall. It went over the side. Where did you go? Oh, there it is. Found it. Jesus. Can't believe I find so many. Oh yeah, that was not my most intelligent moment. No, they're all like stuck on. Ugh. At least if I break them, I can just order another PCB. Okay, so these should not go back on. Oh. Oh my God. That one is really in there. I think they might come off now though. Yeah, there we go. Okay. I'm gonna take a quick look here at the solder joints. Do you have this PCB in production? Like, do you have one of these that you have together and working? You don't. But all you change was a bumper location. So the thing is though, if you changed the fill, sometimes do you know which pin the bumpers go to? Let's just see if they're continuous. I'm thinking there might be a trace that got cut. Get out of there. What's holding this in? Oh yeah, shit, the antenna. Add some debug code to help trace where the... Yeah, I guess. That's over and above my abilities, though. Everything looks fine in KiCad. Let me see here. I'm just going to take a quick... Looks like D47 needs a resolder. What does D47 do? D21 could use a resolder. Don't forget, this is a bit different to the full experience because I can't get right in there to see the soldering with a webcam between me and the workpiece. D47 and D21. You'll have to check on your end what those do. I don't think it's a power or grounding issue because the Arduino is doing the power. 21 is the gyro ping. Well, that would explain some things. All right, let's see. See, I can't even see it. 21. I think it's right there. D27 is one of the bumpers. Oh, you have it open. D21. Not hot enough. I'll just run through the pins again. That fixes, that would be wonderful. Otherwise, check GitHub main.cpp. I don't know what that means. Oh, that one of the code base things. I did tell you I was a coding imbecile, right? This is loose, which is really bothering me. And then, yeah, that one's done. So it'll look pretty good. Ugh. All right, let's put the antenna back on. Okay. Move this shit aside. Put this screen back on. Look at that. You're getting praises. This is a friendly channel. All right, here goes. There we go. That was it. Look at that. Do you have to initialize it? Oh, I see. It only checks relative. If you hold it up, it'll drift back to 0. Yeah, that's okay. So that's one of the things changing to a RP2040 is probably going to solve for you, because they I think these run at 16 megahertz. Screen going, the gyro, yeah. I think these run at 16 megahertz. The Pi Pico has now been certified to 150 megahertz, which is crazy. A, B, C, D, B. Can you, can I also make another suggestion? Keep the A, B, C, D in that position. Just light them up when they're on or off. Like, don't justify that side. Just keep the A, B, C, D in the same spot. That works perfectly. Oh yeah, the screen, this is my frame rate of the camera. There, you can just about see it there. Yeah, it's the exposure. The screen does not flicker. It looks brilliant. Actually, OLEDs are incredible. What's E? E is this? Oh, there we go. That would be perfect first feature. Nah, pass. Thank you. Use any input. Rotary encoder. UI dial. Look at that. That's brilliant. How do I go back? A. Settings. NRF address. This keeps going, but you don't go any further. Let's see if we can overflow your code. 170. It's probably a 8-bit value, so we got a long ways to go. That's how we'll do malicious code injection through here. Okay, A home. Just debugging number. Oh, gotcha. It looks great, honestly. Oh, there. That's a number again. It seems to work friggin' fantastic. I would say I have to order some rechargeable 9 volts, because yeah, this guy just fell flat on its face. Hold on, let me turn off this 3D printer. Done. Get out of here. I forgot I was doing this for an audience too, so thanks for mentioning the flicker. Let's see if these springs... Oh, what a mess. Okay. It seems like shrinking it was a bad idea, because now the arms are so flimsy. Let's see. I may have ruined the front of this too. Yeah, I am surprised too, but it must be because the input is floating. I bet you if you were to put like a pull down resistor or something, it might work better. I'm not sure which input of which part of the gyro. Yeah, you know what? I think for me, I might just extend these button shafts up higher, because like I don't think my printers are capable of printing high enough fidelity for these buttons. You need to reprint the top with better tolerances. Yeah. So to print with better tolerances, I would just have to try a different printer. But I will tell you the Elegoo, well, the Elegoo is 0.6 mil, but yeah, this is not, it's not going to work. I would probably, like personally, I would make caps to go on here that just go straight through here, and then that would accept these guys, because I don't see this. I don't see my printers printing this unless I would probably glue them on. Unless I tune the Voron, I don't see my printer being able. Actually, it doesn't matter if I tune the Voron, because I can't get this on. It's too big. So yeah, I think I would just extend this through the case, because I'll try like this one. This is another print, still the 0.6 millimeter nozzle, and yeah, these don't fit in either. Capture them under the cover. Yeah, could do that too. Capture what under the cover though? Like it would have to sit in here somewhere, right? And then we get the same problem. And don't forget, you have to really try to get that on so they wouldn't be able to fall. Although you could put a dab of glue. A dab of glue, yeah. But yeah, look at how shit. Look at all the warts in here. The printer left behind. Put a lip around the cap so I can't go through the cover. Yeah, they would have to be secured this way though. I will tell you, this is the support still left on here too. I will tell you though, I'm close to just yeeting all my 3D printers out the window. The only one I like is the Voron. So probably I'm going to do a hardware swap on the cheap Chinese one. In PETG. Because if so, I will turn back on the printer. Get off of there. This is the cheap Chinese plate that PETG sticks so incredibly well to. And I only got this plate because the printer forgot that it was a printer and ran its head into the soft bed. All right, turn this on. Oh. Tool, preheat, heat bed to 80. Look at this though. This is a nice project. I like it. Holy smoke, 1 o'clock. Yeah, I know. I need to eat lunch or something. I'm a little shaky because all I had today was caffeine. But that's okay. Once we print Acert's thing, I think these springs are just too fiddly. Sucks about the 9-volt too. But what I like about the design, the bottom is flat. So you could install a battery pack that fits on the bottom, and it plugs into USB-C to plug in. It plugs into the Arduino, so you can use like a power bank IC, and you turn it off, and you have two 18650s sitting this way, and then you plug into there. You attach this onto here, and then you can flip it on, and it turns on the power. I'm a big fan of 18650s. I've got an ammo can somewhere with a whole bunch of 18650s that were just taken out of power tool batteries. And so I use them everywhere. And in fact, I don't think I've ever shown this on the main channel, but this is my this is my mic. This was sent by a patron. And on the other side, I have a TP4056 module to charge and protect the cell. I can put two cells in here in parallel, and I have a boost module that will boost the 3.7 volts. Oh no, it's a buck module which drops the 3.7 volts to the 1.5 volts needed for my AA battery, which is in here. So it goes in there, and it just acts like a AA battery, but it means that instead of this running out of battery every 2 hours or so, I can run this all day. And so since it's just in my pocket anyways, a little bit of a dog's breakfast, it looks like shit, but there, now I have a USB rechargeable battery pack. And I just charged this up before we went live, and let's see what the voltage is. And this was a viewer sent me these 18650s. So we're still at 3.9 volts. So we still have, so we've been going for 5 hours, and we're not even halfway done the battery. Check the STLs folder. Okie dokie. Did you like my hacking on the Platformio? GitHub. Here. STLs. What am I looking for? 2 weeks ago. 1 minute ago. Button cap if the springs don't work for you. Yeah, that's me. Okay. Oh, I see. Oh, you're gonna run it, put it through. Okay. Save. How am I gonna? Okay, print that facing up. You'll see it. Okay, so Kira. Like so. Button cap. Prepare, we're gonna flip that on its head. And then we're going to multiply selected. I'm gonna make only 2 extras this time. Arrange all models. There we go. Letters are gone. That's okay. This will work. That's fine. Slice that bish up. I'm going to go get my USB drive. That's how old this printer is. It still uses USB. No, what's it called? The only thing is the buttons are going to be black now, though. What's it called? Whatever. Save. Eject. Let me know if the top part is too thin. Well, we'll see. I'm gonna have to reprint a whole bunch of parts anyways, because I want it to be, want the handles to be purple. Confirm. It's gonna take a little bit. All right, let's reassemble this. So I assume I can reassemble it without, and put the buttons on after, right? Maybe fix the battery door. I can't. I have to reprint the case. It's way too. I have to redo it, because yeah, it's all destroyed. Whoops! You guys, you can't see shit. Here we go. Webcam. So I have to reprint this half because it's all chewed up, and I'll have to shave it down. So this won't be the final version for sure. That is 100% sure. But I do like the terminals here. It would be a nightmare for you to do that for all your kits, but like so, like so. Keep in mind with this new solution, you cannot remove case top. Okay, that's fine. Yeah, I'll connect the 9-volt, but it's not going back in. I do really appreciate that you left the USB available, you know, through the, you could still access the USB even when it's assembled. That's a really good touch. How long is this print going to take? 11 minutes. Such a short print, but it's such a long prep time. All right, Curtis, thanks for being here. Enjoy your day. Having to take the case off the code would be horrible, yeah. But that's the thing, like, you can't take that for granted. Just because you thought of it doesn't mean others would have also, right? So you do have to take your, you know, what do you call it? Take your laurels, take your pluses when you can. You have to accept the fact that you did something good. In fact, if you look at commercial products, usually they don't expect you, they don't want you to open it at all. So you end up with a product that is really hard to fix when it's broken, because the manufacturers have the nerve to assume you're just going to buy a new product every time it breaks anyways. So they don't care. So like nothing more frustrating than trying to fix a commercial product that was only supposed to last a couple of minutes anyway. Okay, let's put this up and over. Like so. Put one of these guys. Gotta take my magnifying glasses off. They're hitting everything on set here. Yeah, I might design something like that. I may. The thing is, I would have to use the step file, I think, because I would get rid of this, and I think I would put heatset inserts in here to tie my solution in. Because now I'm just thinking I would just use the contacts in there or use the plug in there. But especially if the NRF, you know, is working properly, shouldn't be hard. Okay. If the NRF is working properly, like it looks like it is, this could be a neat little controller for all sorts of things. I've tried my best to code the NRF, it just doesn't work. You have to be some sort of genius. There we go. The printer is just doing its auto leveling now. So it's almost ready to print. Oh, it's doing the purge. It's purging now. So now from this point we have 11 minutes. And then I'm going to be thrilled to go eat something. Do you have a receiver project we can test it on today? No. I could put one together. But I have been streaming for 5 hours. So if you really want me to, I'll do it. If not, I'm going to go eat something after the buttons are done. I do have like a bunch of micros. Like, what do I need? A Pro Mini? These all work. That's good. We're just going to gently put this one on, just for the looks. We're going to gently put this one on. Wherever it went, over here. Anything? Well, it needs to be the correct micro, no? Or else it won't work. There we go. Okay, so that's all set. Okay, let's see. Because any microcontroller that can use NRF. Yeah. So, first of all, will these NRFs work? So I have the big ones too, but will these guys work? These are 24 LO1s as well. And then here I have a Uno. We can just plug it into the Uno. Okay, where do I find the pinouts? Do you know the pinouts? Screen. Let me see. Go here. Cancel. Import Arduino project. Select board. Arduino Uno. Where do I go? C. Windows Desktop. Desktop. No. Yeah, I know. Which pins did you use? This PC desktop. And desktop. Code. Simple receiver example. Import. Okay. Yeah. Like what pins do I connect to where? Test. README. Main. Should be an NRF file. Lib. Include NRF. I don't know, like, what? SRC, NRF. Okay, it says CE pin 49. Uno won't have 49. CSN pin. So do I just change that? So CSN pin 4, I can do that. But CE pin, what does it have to be? Any PWM? Think so. This would be perfect thing to ask AI. Okay. But okay, wait. Does that just use an Arduino Mega? Because I could just use a Mega, right? I have a Mega. If that'll be easier, I'll just do that. Like what did you code it on? 42 digital. Whatever works. Yeah, but okay. What do I use to not change the code? Let me put it that way. Because 49. Use a teensy. Oh God, I do not have a teensy. Yeah, that would be like a fortune. Let me webcam. Change those 2 pins. Okay. So CE pin. Fine. Let's do it this way. I need to use NRF 24L01 and an Uno to run some test code. Oh, Jesus. To run some test code, I need to figure out which pin would be best on the Uno for CE and for the CE and CSN pins. Any ideas? No. D7 and D8. Any digital pins. Okay. Common practices. D7 and D8. So 7 and 8. Wait, which one's a CE and which one's CSN? CE is 7. 7 and 8. Okay. Okay, and how do I wire up my NRF now? Wait, it says 9 and 10. Okay, whatever. Sure, 9 and 10. So CE 9. But I don't have to change the pins in the other parts of the code? No, I'll just put a cap. Don't worry about that. I can solder a cap on. And what pins do the outputs happen on? These CEs and this won't work. Because look, it doesn't change it everywhere. So that's 7 and 8. There's 9 and 10. Is this not the receiver code? Oh, simple receiver. Why? What the hell is this then? Code simple receiver. Oh my God. Okay. Control Z. Put that back. Code simple. NRF. Simple receiver. SRC NRF. 7 and 8. Okay, how do you close it? How do I just want this gone. Can I just, this gone? Code simple. Go away. Go away. Minimize it. Okay. So this, okay, NRF, so 7 and 8. Okay, but what pins are the servo on? 3, 5, and 6. Okay. All right, so let's do NRF 24L01. Pin out. No. I don't know where IRQ goes. Okay, let's go back here. What is this? These are the ones I need. I ordered these brand new. Okay. So I need a ground. Is this black? Ground is number 1. If I'm looking like this, ground to ground. VCC, which is across from ground. And I do believe that needs to be at 3.3 volts. CE. We decided what CE is, and I don't remember. Oh, come on, you piece of crap. CE. The buttons should be done, by the way. CE in VS Code 7. Pin 7. Oh, here. CSN. Pin 8. Serial clock. I don't know. It's just a serial clock, I think. Clock to clock. Mozzie. Oh, come on. Mozzie. I don't know which pin is Mozzie. Seven and 8. Yeah, those were the CE and CSN. Serial clock is actually 13. So 13, 11, 12. 13, 11, 12. Yeah, 13, 11, 12. Go. 13, 11, 12. and 12. Yeah, I needed this side too, but whatever. Okay, and then your PWM outputs on your thingy, they are screen. Oh, 3, 5, and 6. Three, 5, and 6. So I'm just gonna hook one up because I've got a servo around here somewhere. I'm supposed to have a servo here somewhere. Anyways, let's just program this. Gonna need a micro USB. Did see one down here earlier. There's micro USB. My hands are freaking shaky. I haven't eaten anything. Screen. All right. Simple receiver example. That's good. Port. No port yet. Port. COM8. Now I can upload. Failed. Access is denied. Okay. So we go into Platformio. Upload. Failed. Fuck my life. Oh. Change device. How do you change device again? Oh. How the fuck do I do that? It says the board is nano at mega, yeah. How do you change the board now? Environment, new terminal, serial monitor, test, warnings, COM8. I don't know how to change the board. I have no idea. Maybe I can put the name. Oh my god, I just opened World of Warcraft. Okay, back to here. What is the Platformio variable name to set it to program my Arduino Uno? Board equals Uno. Platform at Mel AVR. Failed. Atmel AVR board. Oh, Atmel AVR board equals Uno framework equals Arduino. Didn't work. Wait, it says environment up here. That's not good. Environment. I have to change this. I need to change this. I need... Oh, environment Uno. Okay, environment Uno. Uno. Giver. God, Platformio sucks. Never use this shit again. Failed. I gotta try again. It was doing something in the background. Failed. This isn't working with my Uno. Oh. Okay. Whoops. Upload. Honestly, I'll take long over this shit any day. Okay. That's done. Okay, so we got this. Hang on, we've got serious business to attend. Webcam. Because our buttons are done. Oh, there's a little bit of goobers, whatever. They work. They're slightly too short. They do work, though. The bottom ones feel slightly too short. Whatever, it works. Okay, so that's good. Now I need more USBs. You're gonna find this so stupid, but I'm just turning on my test equipment up top. Okay, that's on. That's on. All right, now where'd my servo go? I better go get a small servo, or else I'm gonna freaking burn things. Since it'll all be USB powered anyway. Ooh, Jesus! Oh my God! Okay. Get the RC stuff out of storage. No, those are gigantic servos. Don't want that. There we go. There we go. Little puny little servo. Now I want male to male. Male to male in the breadboarding box. One, two, three. Okay. Ground to ground. Power to power. And signal. NRF address is hex 01. Okay. And this will be pin 3. 0, 1, 2, 3. Well, something happened. Okay, so now I go menu, settings, NRF address. This is horrible. Why? I would make it, I would move with these and I would switch with this anyways. Enough me complaining. Oh no, and you can't go around. Okay. H. E. Hex. This is backwards. You should have the, you can hold the button, yeah. But the punctuation should be last. Hex 01. Okay. Back. 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 Not working. Not working. Gotta restart it. Okay. Will do. Not working. Gotta restart both, or? So I think the problem is that your pins are not, you're getting Wi-Fi signal. Okay, so 3, let's see what the other pins you're using. NRF. Source main CPP. 3, 5, and 6. Try restarting the Uno, sure. So that's 3. 5. Oh, that did something. So it's detecting it, but it's not moving. 5 and 6. So the code is definitely running, but it's not changing the position. So 3, 5, 6. But they're not moving. So the other thing, it could be the capacitor, right, as you were saying. So what I can do is turn this off. Oop. I got my soldering iron is going, and then I'll just solder a cap across there. Oh, here's the front that I printed out of PLA. It's really nice. Actually, you know what? I'm gonna see if the springs fit in there. still don't fit. Cap. Capacitor. Pots and caps. Well, I'm guessing it's because your Platformio code, we only really changed 2 of the pins, not all of the pins. So it's just not, you know what I mean? It's just not, it's not just not going. Let's see. White this way, yeah. It's because the other 3 pins are always the same. I do have 1 pin not connected. But I heard that one's not necessary, the one down there. Ouch. Library takes care of it. I don't want to get solder all over this. Okay. Let's try this. Nothing. Let's change the pins to what Perplexity was saying. CE CSN 910, but we changed that in code. 13, 11, 10. Okay, same thing. Dude, so sorry. The A toggle. Switch off the A toggle. Oh, there we go. That's like the arming then. Oh, she died. Don't know what happened. There we go. Back to life. Yeah. Oh, I think I'm browning out my Arduino. I think what happened is I browned out the Arduino. That's what this cap is for, really. It all works. Well, thanks a lot for sending the kit, but that is it for me and for custom making these buttons at the last minute. Really appreciated. However, if you're listening to this and you want this hardware kit that you'll be able to 3D print and it'll go a lot better. Oh, yeah, look at the X. It browns out. The Wi-Fi browns out. This is a beautiful piece of design. I would say you have to make sure your 3D printer is up for it. It is a little bit of a challenging print, but other than that, the hardware is great. You got a nice big OLED down here. This is what I would expect. Oh, look, we've browned out the Arduino again. Yep, no more transmitting. Oh boy. Maybe I shouldn't run this off the LDO. Oh yeah, it's pretty warm. But anyways, this thing works absolutely great. And I'm gonna go eat. If you guys wanna get your own hardware parts kit, go down to the link in the description. You'll see Acert's website is there. You can pre-order the kit. Everything works absolutely phenomenally. And it seems like this is the kind of thing that you can just pick up and make work yourself and, you know, have your own custom whatever at the end of this. So this works really well, and I can't wait to mess with this some more. Make sure to subscribe to Aecert Robotics. He's been in chat all day, which is 6 hours in 7 minutes, by the way. So yeah, really glad to have you guys here. Thanks for watching, everyone. We'll catch you in the next one. Bye.